Hello!
We're live.
Good afternoon.
How are you guys doing? It's good to see you all. Tonight we've got a special guest in, guys. Lumpygasinavacuum. Glad you could make it. And PJ Cruikshank. How are you guys doing?
Yeah, good. And you gentlemen.
Oh, it's always good to see.
And welcome all the people in chat and on listening live.
Yeah, definitely. Tonight's a special one. It's about celestial navigation. Obviously, I'm going to show some Proto Thad stuff, whatever his name is, Proto Thad. As he's hectic into the globe cult, and he strongly believes celestial navigation is based on globe. So I thought we'll go through some of the stuff because it's quite funny.
Cool.
So let's see who's in chat. Well, it's good to see you all. We got PJ Cruikshank, obviously. Lumpygasinavacuum, hello. INFE, Arwen, good to see you. HGD Rock, which is Sean Hawkins. PT194, Plain Truth, thank you for coming. Flat Earth Canada, it's always good to see you, mate. Flat Earth Canada, I just said that. Jeff Gashead, hello. Tony Whitcomb, thank you for coming, mate. And then we got, I saw some more people. Derek Nelson, Captain Caveman, Effie Nation, Mark, and yeah, that looks about everybody. It's good to see you all. I hope you are doing well. Are you guys ready for tonight?
Absolutely. Oh yeah. This will be good. It'll be fun. This guy's a real treasure.
So yeah, celestial navigation is based on horizontal reference. Yes, 80%, which is the truth, guys. No, 20%, and no idea, 0%. Yeah, Owen, ball busters in 30 minutes. Sorry to tell you, I'm not going to make it. But it's good to see you guys. Great, you can all make it. You can start now. My permission is pending, Tony. Yeah.
Hey, Tony.
If you guys haven't already, please do hit that like button and share, as it does help to push the show out further. I must say, I'm still recuperating from last night's long show.
Yeah, it was a long one.
I didn't get much sleep. I did actually get some rest today. And I've told my wife, it's like 3:30. I'm just going to lie down for a half an hour because she's taking the child to sleep. 2 hours later, oh. Yeah. So at least I had a good sleep then. So the last night's stream to me, I thought was epic.
It was good, very good last night.
Yeah.
It was really good. Bob almost made the show with his incoherence. It was wonderful.
Yeah, definitely. And I mean, I enjoyed having Rocket on. Come and have a chat. He was one of the nicest, politest ballers I've chatted with in a long time.
Oh, definitely, he was a really nice guy.
Yeah.
Very amicable, very approachable.
The only problem is he falls under the same cogdis problem though, where he just has to try and ignore the evidence. But I do see some kind of hope in there that he's realizing the issues, and maybe he'll decide to come around. You never know.
Yeah.
Hey,
I've seen him around a long time over on 24/7.
Okay.
He's been around a while.
Okay.
Yeah.
Hey Mandela Effect, good to see you, mate. Glad you can make it. Okay, guys, so I decided let's start with one of his first videos where he's demonstrating celestial navigation on a globe. Okay? Yeah, just so we have the context on what his argument is. Okay, you guys ready?
Absolutely.
Let's do this.
Yep.
In this video, I will be demonstrating the principles underlying celestial navigation, specifically how...
Someone's mic or something's making a lot of back noise. I think it might be Lumpy.
It's me.
Yeah.
Yeah, there's like doors and stuff around that.
Do you think we might be able to pause?
Let me see where my mic.
Oh yeah.
What I can do. Oh, sorry. I might hop out. if I don't see the microphone button.
Otherwise, all we do is
You know what, guys? I just go to chat.
No,
I'm alright to go to chat.
No, but
Alright.
I like having it. But yeah, if you want to go to chat, it's fine. If you have something to say, you just pop in again. How's that?
Okay. Got
Okay.
it.
Short man, thanks for coming in. And yeah, guys, Lumpy might be doing a presentation sometime on Entropy. That would be awesome. So
Cool.
yeah, because he's really excited about it. I'm excited about it because he does know his stuff. Mandela effect says, I believe that I've worked out what causes the ice age on the flat Earth. That'd be interesting. You want to come and present it sometime, Mandela effect? Let me know. It'd be great to have you on to come and do so. Okay. So, I hope it's showing on screen. This is his first video where he's demonstrating celestial navigation on a globe. We're going to go through it and we'll see what he comes up with.
How circles of equal altitude intersect at the viewer's position, showing their latitude and longitude coordinates. To do that, I will be using a educational globe.
Educational globe. Hi Jumbo, good to see you. And hey, Better Than Gold, great to see you. Thank you for coming. Yeah, Lumpy is a very smart friend, for sure. These globes are used not for educational purposes, by the way. But yeah,
No.
if you say educational globe, it just means you think it's educational. A globe is not educational at all. It's indoctrination.
Yep.
Yeah.
That you can draw on with dry erase marker. And I will also be using a drafting compass that I have a dry erase marker attached to. And I've also created a ruler-like scale that will allow you to determine the degrees of longitude at various latitudes on the globe.
Great. Yeah. So on a piece of paper, in other words, printed it out so it can form to his sphere. Weird how it also starts out as a horizontal. Already making one of the points of flat Earth here, Proto. You know this ruler you made here? Is it curved? Or is that a horizontal? Yeah.
Yeah.
It's very simple stuff. Okay, let's get going.
So let's begin. Okay, so the first star we're going to do here.
Exactly, Lumpy, a flat piece of paper. A horizontal flat piece of paper, by the way.
Exactly.
So even his own equipment he's using requires it to be flat first. Tony Whitcomb, £20 super chat. Thank you very, very much. Appreciate all the support, man. It's insane how much support you guys are giving. I really, really appreciate it. He says, Globers only have a voice in comments. After the stream, freaking cowards. Yeah, but that's it, Tony. Just like Bob the Coward. He comes in chat for 3 streams and hasn't got the balls to hop in to actually talk. I mean, I have literally, he says he wants to debate me. I said, sure. When can I set up a debate on modern day debates? And what's your topic? He hasn't answered me at all. Well, funny enough, today I got, what's that, Flataholics Anonymous or whatever his name is? The one of the trolls, you know? He said he would be more than happy to debate me. So I said, yeah, so when you're going to come onto the show? He still hasn't replied. So, yeah. Hey, SI man, good to see you. But that's about it with Globers, guys. They all just bark and no bite. Because they mostly work off of parroting and scripts. So when they have to come live like this, straight on, they suffer because they actually don't know what they're talking about. Hi LSG, thank you for coming. Great to see you. Okay, let's carry on.
Duper already, duper poons. The horizon is apparent, so it's not actually flat Earth. Well, how did you come up with them conclusions?
Do you, Dupapoons, do you know what a horizon is? Do you know because it's apparent over a horizontal? Horizon means horizontal plane. Yeah.
It's in the word. It's in the word.
Here is Procyon, which has an altitude angle adjusted for refraction of 25 degrees 12 minutes.
Altitude angle. What is an altitude angle? How do you get altitude angle, guys? Would that be based off of the elevation angle?
Elevation angle, yeah.
So, yeah, he's already got everything worked out here. It's amazing that he doesn't show you how he works it out. He just sticks it in there, all information. Start with the Greenwich hour angle from Aries. Column, look up the minute and second adjustment. Look up sidereal hour angle for the star. Add them together for full Greenwich hour angle. Yeah, because that works off the azimuth. Congratulations. That can be worked off the Gleason's map as well. Okay, so this declination, 5 degrees, look up the right next to the SHA for the star. You know, all this information they give you is not based because of a globe. It's based because of thousands of years of observation and knowing the times and the locations for the star at that time. So the GP of that star would be seen at this time and hour and location. That's how it's practically worked out. Then they've back engineered those observations to create the nautical almanac, you could say. Philip Dick, thank you for coming. He says horizon means... he retracted it already. Yeah. Funny thing is I can't see Duper on my chats though. Oh, there we go, Duper Poons, I can see it. It's an apparent horizontal. Yeah, an apparent horizontal. Because the apparent position on the horizontal, you know what I mean?
Which gives us a co-altitude of kind of pretty close to 65 degrees. So we are going to then size...
Okay, wait. I just gotta go back here. Ground position, correct? That's the ground position. His co-altitude angle, which is based on elevation angles, is 64, okay? The distance to the GP from his ground position is 3,890 nautical miles. That creates a triangle, correct? Because it's based off of a 90. So, I just have to say to all the Globers that's moaning that I use paint, I like using paint because it shows how easy we can debunk you with crayons. This is a 90 degrees, guys. So, a co-altitude angle would be something like that. Where this is the co-altitude angle. This is the measure. You see? Get it? So, the GP of the star would be GP of star and GP of you. Now, this distance between there has the same circle of equal altitude, the same horizontal. Horizontal. Get it? So that means from your GP to the GP of the star, based on his, is 3,890 nautical miles. Flat. You're creating a triangle because that's a 90 degrees for that GP and a 90 degrees for that GP. Get it?
Philip Dick says the horizon goes up and down. When do you know it's horizontal? It doesn't matter if it goes up and down. Something that goes up and down can always still be horizontal, whether it's high or low or in the middle.
Philip Dick, let's put it this way. Have you ever looked at a train track in the distance and there's a train? When it goes further away, the train, does it seem to look like the train's getting smaller? So it looks like it's lower than your angle. But when it gets closer, it gets bigger, correct? That train. Does it literally rise? Or is it just seeming to rise because the angular size change? It's called foreshortening, mate. You might want to learn about it. So, yeah. Let's carry on.
Gives us a co-altitude of kind of pretty close to 65 degrees. So we are going to then size our drafting compass.
Okay, I just have to say this. Sean, He says 2,500 years of measurements and experiment. Your cult can't even measure your flat Earth. Again, Sean, we've said this maybe how much times? Andrew Johnston came and presented the flat Earth measurements for Earth. And by the way, show us 2,500 years ago where you had measurements and experiments. You don't even know what an experiment is. Mandela Effect says, I've noticed how you have to explain the same way you would explain it to a child and they still don't get it. Exactly. Philip, foreshortening is a normal perspective. He retracts it again. Yeah, because you realize how stupid your comments are. Hey, Dyson Bones, thank you for coming. Good to see you.
To that, now that's a fairly large degree, this drafting compass, so I've learned I have to move the marker way out to the end. Makes it a little bit more challenging.
I just have to say something about this, guys. Protothad, when last have you seen people on ships when they navigate sitting with globes to navigate? They use maps, correct? And they have their compass and everything for the circle of equilibrium on a map, a flat map, not a actual globe. By the way, is your globe a spheroid, oblate spheroid, or is this a perfect sphere? Sean Walker says that is a lie, and you know it. Spherical axis is impossible. What spherical axis, Sean? The triangles were less than 180 degrees. 4,000 kilometers of horizontal surface distance measurement over land. Yeah. Again, the Nautical Almanac uses spherical trigonometry as back engineering observations based for thousands of years. Those GPs and stars times have been around before your globe even had an inkling of an eye to exist. They knew the GP and the star's location and times many, many years before your globe even tried to exist. And long, long, long before nautical almanacs existed. Yep. Yes, flat maps with thousands of square miles. Exactly, because they work on a coordinate system. That's all it is. Celestial navigation is based on coordinate systems, guys. Hence why that coordinate, ground positions, coordinate system. It's not shape based. The measurements, though, are based off of a horizontal. Otherwise, you can't get your angle measurement. Hey, Klebricus, good to see you. Thank you for coming. Glad you can make it.
Large degree, this drafting compass, so I've learned I have to move the marker way out just about as wide as it'll go.
Okay.
5 degrees, 10 minutes north, 150 degrees,
28 west.
27 minutes west.
28 west, not 27.
Right about.
Why is he saying 27? Did you guys see that? He just said 27, correct? So he's marking it wrong. You see why I'm saying he had the horizontal paper that is now making curved? You know why this is, guys? Let's quickly do this again. For the people that haven't realized, wait, now I'm going to do it this way. Because of this. The horizontal, that would be that horizontal ruler that he's got. What happens when you are measuring to the sky? You have a field of view that creates an arc, aka the celestial sphere. So, the distances are based on the surface by measuring an angle to the celestial sphere. Hence, the hypotenuse distance gives your distance relative to the horizontal on the floor. There it is. Simple as that. So that's why he uses the horizontal ruler curving on his globe. So he's simply measuring now a distance over the celestial sphere that he's thinking is now the physical sphere. Hey White, good to see you. Thank you for coming. The baseline needs to be horizontal. Very simple.
There's where we want it, I think. So that is our...
I still want to know why he said 27 degrees when it was 28.
DP for that star.
28 minutes. He said 27 minutes.
Our drafting compass.
I mean, wouldn't that make a huge difference? I mean, one minute of arc makes a huge difference though, does it not? Especially with a longer distance. The longer the distance, the more out you would be. Yeah.
Yeah, Duper, Globers have been telling us that for years, that if you zoom in on a basketball with a telescope, then it's got to be flat. Yeah.
Yeah,
Not
congratulations.
big, flat.
Have you ever heard of focal length, Duper? When you take a camera, please show me a size camera like you're taking to a basketball on the earth. Let's do it this way. Maybe I can't believe I have to do another thing on paint for these guys. There we go. Okay, this would be the basketball, Duper. This would be the size of the camera. He's zooming into this piece, Duper, to make it look flat. Do you understand the size of the camera compared to your basketball earth? That is the issue that you do not get. Now, if you have to take it to true scale, you're supposed to be... Can you see that dot? No, you can't. Even that dot is too big for the camera. Simple stuff. Hey, Lumpy.
Hey, Flatsman.
Yes, mister.
Hey, I got a question. Do you happen to have a ball at your house?
I have two.
The reason I'm asking that is because you could...
I have
You
two.
do?
I have two
Okay,
because I made a lot of
well,
children.
So why I bring it up is you could put your finger on the spot where you're describing where the measurement's coming from, and then put your finger directly out from the center, what would need to be the 90 for the GP, and then show the angle in correction, because wherever the ground position is, and he's got that going around the globe there, that would have to be directly up from the center of that ball.
Okay.
Right? Directly, if you had your feet on the ground or your head faced directly up over you, like at noon for the sun.
Yeah.
Well, that angle would screw up your geometry because you're already laying down your 90 degree, because you have to look directly up. Your two zeniths, so you're directly up from the measurement and the directly up from where the ground position are, need to be parallel.
Yeah.
And they're not on a sphere.
Exactly.
They're just not. I wanted to add that real quick, but maybe a little visual sometime with the ball. I mean,
I've got a ball in front of me. I've got a ball in front of me.
You just got it on the screen now.
Sure.
Okay.
All right. Well, yep. All right. I just wanted to jump in and say that. I'll come back later.
Okay, but what do you want me to do with the ball quickly?
Well, if you can look at what Proto had
Yeah.
with his globe, and where the ground position for the star,
Yeah.
right, needs to be directly above to make that 90.
Yeah.
Well, on
Okay.
the ball, it's going to be laid down, so you're going to have an obtuse angle.
Exactly.
Because where you're standing to take the measurement with the sextant, and where your ground position are, you need to be able to look directly up and have the zeniths be parallel, or your triangle screwed.
Yeah.
Yeah.
And if it's
And he's screwing it up right here, as plain as day, and he's doing it to himself for the whole world to see.
exactly.
It's amazing.
It's sad,
that
and
he's-
they're blind. They're so blind they don't even realize the problems. That's why I was
Yeah, I
trying
just
to
was-
point out the horizontal ruler he used. That's why I pointed it out.
It's really bad. I mean, and I wonder, like, if you could tell the person that, and if they can even figure out what you're trying to say, or if they're just liars,
I think it's a little
or
bit
they're
of.
just
It
trying
might be
to wear us out.
It might be a little bit of both, though. Sorry, guys, I got a £10 super chat from Tony Whitcomb. Thank you very much for the super chat, Tony. Really, really appreciate it. He says, funny how Globus say you should see thousands of miles, yet don't say, but refraction, you can't see that far. Very, very true statement. It's either too big or it's too small. They very selective. Thank you very much for your super chat, Tony.
Say, guys, we got to get that, that when Bob said that he could see the back of his own head.
I'm going to make a cut from
Get
it.
a video of the back of his head.
No, that would be
like, find out how flat it is. That would be hilarious. All right, guys, I'll come back.
Shot, thank you,
That's
Lumpy.
wicked soundbite.
Yeah, it's going to definitely be a soundbite, that's for sure. There's a lot of sound bites we can take. But that's why I had to replay that over and over because it was insane.
I know.
We've got 57 votes already. Celestial navigation is based on horizontal reference. Yes, 79%. No, 14%. No idea, 7%. At least the people that say no idea are honest. But the people that say no are either just liars or, yeah, liars. That's about it.
Duper says, if the camera is fat enough, the earth can be small enough for the camera.
It doesn't change. Remember, a camera has actual size. It doesn't physically change size, Duper.
Exactly.
Angular size doesn't physically change it. It's an angular optical size. That's the problem with these guys. They don't understand optics. Not at all.
That's it. That's it.
Okay, but let's carry on.
On the GP for Procyon, we draw in our circle of equal altitude.
Mandela. Yeah, see, back of his head means he would be able to see how empty his head is. But like I said, since when do ship navigators take a globe like this and take a compass and start drawing circles around a sphere? They don't.
So there we have our
No.
circle of equal altitude.
They usually
for
sit with maps like the Mercator map projection and stuff. In World War II, they used the Gleason's map. I don't think the globe is like that, but yeah, World War II, a lot of placed countries used the Gleason's map for their world. So they knew how to navigate. Weird that, don't you think?
Yeah. Duper, it's perspective. Oh, I'm glad you're starting to recognize it.
So apparent then, optical, thank you Duper.
Jump. Okay, so next I'm going to do Arcturus.
Sorry, what says the World Geodetic System, WGS 84, is actually based on flat Earth. All navigation begins with flat stationary plane reference. Exactly. The WGS 84 is just taking consideration of the ellipsoid. So they measure it based on planar surveying, which is horizontally based. And then their consideration, because their belief in a globe, they stick it to a ellipsoid. Exactly.
Which is not quite as large a circle in this case.
Oh, really?
Inclination angle, altitude angle is 45 degrees 41 minutes. So that means our co-altitude is just a little bit more than 44 degrees.
And how do you get a co-altitude angle again?
Okay.
Remember I showed you guys the math, how to get a co-altitude angle? There's your co-altitude angle measurements. So if you, let's say, measured an angle of 30 degrees, the star, you would know it's 90 minus 30, which gives you 60. So your co-altitude angle would be 60. And 60 times 60 in nautical miles would give 3,600 nautical miles. Very simple. Obviously, this math is based on every 10 degrees, but you can do it with every single degree as well. And that's based on what? A horizontal baseline. All the math he's just giving you here, guys, this triangle is taken from a horizontal baseline.
44 degrees. And so we will size that up again, like we did with the previous one.
Okay, yeah, previous one. He's just drawing again and sticking his horizontal ruler over a curved surface, guys.
52 would be there. And down about a degree.
Oh, wow.
About there.
Hey, Richard, good to see you, mate. Thank you for coming. Glad you could make it. Yeah, parent versus actual. Duper apparently obviously never went to school. I agree. Well, went to school but never actually paid attention.
He still doesn't get your point, does he? Example, place the camera right next to the basketball. Now move the camera away and the basketball will be small enough for the camera to take a picture of. That's not the point.
Again, Duper, angular size change is not physical size change, mate. Hey, FlipFX, good to see you. Thank you for coming. Glad you could make it. And PT90194 is here as well. He says, when Proto gives the distances from each GP, based on math you agree with, will you show us how to get the observer's position on FE map? I'm guessing no. It's a coordinate system. So you can bring up any map that works on a coordinate system. Look here. That 19 degrees 4 minutes north. You mark that on any coordinate system. 52 degrees 5 minutes west. There's your coordinate system, and then you just draw a circle of equal altitude of that distance. Doesn't matter which map you use. You can use a donut earth map if you want to. It's a coordinate system. Dustin Bo, ach, PT. Very simple to understand. He's just doing it again on another one. And now he's going to have his so-called fix.
We're not going to mark in that whole thing because we know that's where our fix is.
Mandela. I never went to school. That is why I'm intelligent. Well, school does just indoctrinate people. So, hey, Brian Stavely, good to see you, mate. Thank you for coming. Glad you. I actually you had an awesome stream this morning with Rose on and Voynich. Was the first time listening to Voynich though, but I really enjoyed the stream. Thank you, Brian. He's doing an awesome job, guys. If you haven't already, do subscribe to Brian Stavely's channel. He is mostly about Mandela effect, so definitely well worth it to go and watch.
And this gives us this nice little thing we call the cocked hat. This little triangular looking thing. It's not quite a triangle because the lines are actually curved.
So then it's not a triangle. Thank you for presenting us not a triangle and calling it a triangle. Yeah. Is that blue supposed to be water stick to exterior of a spinning space testicle? Apparently, yeah. Because apparently Earth is 70% water. And the physics of water... What happens to what does the physics of water say when it lies flat? When it lies at rest, it finds its level, flat, horizontal. Yeah, Michael really is also on top of the Mandela effect. I really agree. Michael's not unfortunately in tonight on the panel because he's babysitting a dog. So I hope you are giving the dog a great massage and telling the puppy how much you love him. See, you even get flat with dogs, guys.
We know that our position is actually somewhere kind of in the middle of that. So I'm just going to put a little...
Physics is the waters that follows the forces applied on it. Yeah, great to know. So flat then, Philip.
Dot there, indicate where we think we are.
Where we think we are. So, by the way, how big is that triangle that is made there? If you had to take it into consideration on his whole globe. Is that bigger than a county? Yeah, I would say so. Much bigger.
Yeah.
I mean... that's quite... let's actually try and look up where that is on their globe. Do you think we'll be able to find it? It's around about... It's around about here, correct? Around about here. So it's about the size of Minnesota or Wisconsin, you would say, correct?
Yeah.
Or bigger than Iowa. It's between here. So it's between Minnesota, Minneapolis, and Wisconsin. So let's say it's the size of apparently about Minnesota and Wisconsin put together. How far is that distance? I mean, that's quite a distance, don't you think?
Yeah, definitely.
How do you work this? I haven't really used Google Earth Pro that much. How would you work a distance? Ruler maybe. Map length, there we go. Let's just say it's from there till there. That would be 706 kilometers about. So let's just mark it out and say 700 kilometers. If you are 700 kilometers out from a place, you're definitely going to miss your position, aren't you?
Yeah.
Yeah. 600 miles, 700 kilometers, yeah. Hectic stuff.
I mean, that's almost the length of Britain.
Yeah, it's hectic. Hey Hobbs, good to see you. Thank you, Vainan, for coming in. I'm glad you could make it. Proto had that fail 5th grade entry to geometry for sure. What a clown. I'm in Minnesota. Exactly. Yeah, flat earth dogs better than gold. Okay.
So now if we figure out our position.
Oh, using the horizontal ruler again over a curved surface, guys.
Yep.
That dot.
Better than gold. My cat is a flat earther. Yeah, and the cat always lands on their feet, correct? Ah.
Measure it up. That's at about 47 degrees north. And the appropriate longitude scale. It's at about 93 degrees west.
Congratulations.
So,
So,
right
coordinate
in.
systems, guys.
7 degrees north
Yeah.
by 93 degrees west.
Yeah, why doesn't he use a compass on the globe, Flat Earth Canada? Good point. Because it won't work. A compass requires flat surface to work. That's why when you use a compass, you lie it horizontally.
And when we compare that to what the actual answer is, we find out that we actually have it within less than half a degree of latitude and longitude, the actual answer.
Wow, congratulations. Now I want to ask you, look how thick this marker is. What is the distance between that markers? I mean, that's quite a hefty sum as well. I mean, if that was, we worked out like 700 kilometers, that would easily be about 100 to 150 kilometers, just that one line alone.
Yeah.
But like I said, it's all just based on coordinate systems. You can do exactly the same thing on a donut Earth if you wanted to, or a pyramid Earth. It doesn't really matter. Hey Quinlan, 1977, good to see you. Glad you can make it. Now, because he drew it on a sphere, he thinks it means sphere. Yeah. Hey Television, thank you for coming in. Glad you could make it. Okay, so I thought this is interesting to show. So then, something I want to show the ballers, because they do love to ignore this. Is it this one? I think so.
Hi folks, so today I want to talk about sextant navigation. Now I know the guys over at Flat Earth Debate have been speaking about this for quite some time now, and I agree with everything they say on the subject, and in fact
Flat Earth Ken says, Flat Earth, thanks, been trying for years to publicize that. I've known I have so many more proofs of flat Earth because I live in the country. Oh, that's great. It would be great to have you on sometime as well if you ever want to talk Flat Earth Canada.
Touch on a bit of what they say at the end of this video.
Guys, this is Rob Durham, by the way. And I would appreciate it if the Globers actually pay attention to what he's showing here.
Yeah.
Because this literally just takes what Proto did and throws it in the dustbin.
But I want to focus on a different aspect of sextant navigation today. One that perhaps has never been thought of before, perhaps has, but never modelled. And I'm going to model it. So let's start by begging the question and assuming we're on a sphere. And we want to determine our location on this sphere using a sextant. Now bearing in mind that we must start with a sphere, if that's what we're living on. And the geometry must also work on a sphere, if that's what we're living on. Now in order to do a triangulation using a sextant, we use the Mercator projection map as shown here.
So laying it out flat, horizontal. Thank you, Rob, for already making our point. So remember when I said he's using a horizontal ruler, paper ruler?
Yeah.
Yeah. This would be the Mercator map. This is what most of the maps that the navigators use, the Mercator map in other words, which is what? A 2D map. So, yeah guys, please do sub to Rob Durham. I'm going to put the videos in the chat, in my description after the stream. If you guys haven't already, hit that like button and share please so we can get out to more people. So yeah, back to the argument. They have to have a horizontal to have it in a globe. So that's why they use the Mercator map, because it's flat.
But how do we get a flat Mercator projection map from a globe? I'll let this guy explain.
Projection. Popular rectangular maps use a cylindrical projection. Imagine putting a theoretical cylinder over the globe and...
I'm just scared about the copyright strikes on this though. But anyway, he's just cutting it out and they're laying it flat. Okay, that's about it.
To a flat map. In this case, the Mercator projection.
you have a flat rectangular map.
Okay, so we now know how a projection is made from a globe to a flat map. In this case, the Mercator projection. So we all know...
Yes, the Mercator is distorted. Exactly, Taylor. All maps are distorted. Globers don't like to hear that though. I think there's over 1,000 apparent globe maps, and they all have distortion in some kind of way. And they apparently say the globe is perfect. But what's the excuse when you bring out these distortions? Oh, it's difficult, practically impossible to take a sphere and turn it into flat. That's the excuse. Instead of just conceding, it's not a globe.
That in order to do a sextant triangulation, you need to use a nautical almanac to give you the zenith of the celestial bodies. And you draw circles of equal altitude from that zenith to determine where they cross, and hence where your location is.
Can you guys see the issue here? What did Proto just do? He drew it straight onto a spherical surface. Correct? He didn't draw it on a map first. That's just the one issue. Remember, he used a horizontal flat paper ruler that he had to use to conform to the sphere.
Exactly.
He did it that way so it distorts, you could say, manually to his globe. Hey Bobby Zines, thank you for coming in. Glad you could make it. Exactly. The last globe I saw had a sticker on the bottom saying not geographically correct. And they usually say not used for educational purposes.
Yeah, it's decorative. That's it, decorative purposes only.
So for shits and giggles, I'm just going to start by drawing a load of circles all over this map, like so.
Exactly, Dustin Bow says those circles cannot work. They will be distorted. Yeah.
Yeah.
And the navigators on ships and everything, they use like the Mercator map, where they draw their circles of equal altitude.
Mm-hmm.
Do you see? That's the problem with what's his Proto or whatever his name is. He drew
Yeah.
it directly onto a spherical surface, so you wouldn't see the distortions.
Yeah.
It's
If you draw a
dishonest.
circle, if you draw a circle on a globe, and the same size circle on a flat map, it's going to use more area on the globe, isn't it?
Mm-hmm.
Yeah. Yeah.
Exactly, but
Cool.
but I'm saying that's where he was very being dishonest. Why do you think
Yeah.
he drew it directly onto a globe?
Exactly.
Because if he had to do it this way, it would show distortions.
Yeah. Yeah.
And then I'm going to take this map and wrap it around a sphere in AutoCAD.
AutoCAD.
And on first glance, everything probably looks normal. These
Nope.
circles look okay, this circle looks okay, but this one, you'll see it's starting to go egg-shaped. And if we go down and look at this one,
Oh,
which reaches to the South Pole, this one gets pointed. So the circles are okay around the equator areas, although
Philip Dick says no, they don't use Mercator. They have to make reduction side procedure. That's false. They do use Mercator. Even flight plans are based on the Mercator, mate. The Mercator is one of the most widely used maps for navigation. And site reduction tables don't negate using the Mercator map to draw the circles of equal altitude.
they won't be a perfect circle.
Yeah, that's actually true, Taylor. The circles
Yeah.
are referenced to the ground, and stars are not reified map. Mm-hmm. Yep, this is based on the ground, guys. But that's the problem, Taylor, because they take it and they call the celestial sphere measurement parallel to the ground. So they literally duplicating that to the ground, and that's why they have the issue they do, because they find it to be physical then. That's what I was trying to explain with the when I show this. The relationship is the hypotenuse distance to the horizontal baseline distance. That's why you have the curve, because there's a relationship to that hypotenuse distance to the horizontal, which gives the apparent celestial sphere curve.
And the further north or south they get, the more egg-shaped.
Well, Lumpy, do you think they'd be able to show us a triangle on a globe? Oh wait, they have to recreate what a triangle is.
How does drawing circles prove anything? Well, it's your man that's drawing circles on the globe. It's not us.
Yeah, maybe pay attention, Duper.
Or even teardrop shaped they become. And the reason is because when you try to wrap a projected flat map, specifically the Mercator map in this instance, around a sphere, you have excess map. The paper that the map is printed on will not physically wrap around a sphere. You have to take slices out of the paper on the
Hey, NH guy, good to see you. Glad you could make it. The hypotenuse has zero value in the celestial. What? And what? He says that. Wait. Oh, the hypotenuse has zero value in the celestial navigation. IG has a length if many light years. Do you know what a co-altitude angle is? And then you come and tell me the hypotenuse has zero value. Are you stupid? Hey, Guns of Neverone, good to see you, mate. Thank you for coming. Let's go back to my drawing. This is a hypotenuse, correct? Yeah. This is what gives the co-altitude angle, correct? Yeah. You measure this angle, hypotenuse, over a horizontal, to give your co-altitude angle, aka hypotenuse, used. The distance of this hypotenuse to the horizontal is what gives your curve. Not difficult to understand.
north and the south to be able to fit the projection back onto the sphere. So it's taken part of the circles out, and in this case made a teardrop shape. Okay, with all that.
Yes, PT, I go back to my crayon drawing for you guys. Because I have to explain it to like I'm explaining to a child.
Hmm.
The base is good, the hypotenuse is good, but only the height of the star is apparent. All height of stars is apparent. Let me see. I just want to quickly get something. If I can find McToon, where are you? There we go, McToon. I want to go to... Yeah, there we go. Okay, I think it's going to pop up now. Based on this, remember I gave this to McToon when he was on with the so-called orthographic viewer's perspective based. And I asked him to work out the actual height of this. You know, he has still not to this day come back to me on this. And I asked him multiple times for this. Now, what is the degrees we measured? The one was 8.57, other one's 4.7, and one is 3.39 to the same object. Now, does that make the object actually change size? Does it actually make it drop in the distance? No, because it's an apparent angular measurement. That's how it works. It's all apparent. See, different distances give the apparent measurements.
That being said, I'm going to simulate a couple of sextant readings to try and determine our location on the sphere. So I'm flipping back to the Mercator map, and I'm going to choose two celestial bodies to take my angle measurements to. That being this one and this one. So GP is the geographical position of that celestial body above the Earth at that particular time. So this one, reading from the Nautical Almanac, tells me that the radius of the circle I need to draw is 2,000 miles. This one, the Almanac tells me I need to draw a 2,500 mile radius circle. And wherever those two circles cross is a possible location that we are on the Earth.
Yep. Do you get this, Globies? Circle of equal altitude, circle of equal altitude. That means radius to circumference, radius to from boundary to boundary, all over. That whole boundary is the circle of equal altitude. That means it's the same horizontal plane. Same horizontal plane. That distance from boundary to boundary inside the interior is a horizontal plane distance. So in other words, it's not spherical, it's horizontal, flat. Okay? Just to make that apparent to you guys.
So it could either be here or it could be here. If we wanted to determine exactly which one of those it was, we would draw a third, hence triangulation. And the circle would either cross the...
Hence triangulation, guys. Oopsie.
Yeah.
Which the Globers don't like to use.
This one, or it will cross this one. But we're just going to do two on this occasion. And we're going to say that we know where we are. We know we're not on this one.
No, you don't use circles because it's a sphere, Duper. You use circles because that is the max of your field. You know, like when you have a field of view. When you stand, you've got a 360-degree field of view around you. Your max is a radius to the circumference, to your barrier, you could say, to the max you can see. And it's the same way all around your position, hence a circle. You don't see in a square or a triangle, you see in circle. The radius value is the same right around at every degree around you, hence a circle.
A circle's 2D, a sphere is 3D.
Exactly.
We know we're on this one because we started out in Greenland, let's say, and now we're halfway between Greenland and Iceland. All fine and dandy. We've located our position. But what happens if we want...
Exactly, Guns and Neverone. Hey Mike, good to see you, thank you for coming. How would you draw a circle of equal elevation to Polaris on the Mercator map? Simple. you take the point, because it's a coordinate system. You figure out where the coordinate system on the Mercator map is, and you pinpoint it from there, and then you draw your circle of equal altitude. Not hard to understand, is it?
To put this back onto the globe. After all, it absolutely must work on a globe, if that's what we live on.
Hey, Turing test, thank you for making it. Maybe you should pay attention instead of trying to say stupid things.
No, a sphere is, Quinlan, a sphere is not 2D. The argument is the surface of a sphere is 2D.
Yeah.
That's the argument.
And then we go.
It's 3D.
Okay, and PJ, I want to ask you a question. If you go outside now and you take a shovel,
Yeah.
and you dig a hole in the surface, does it have depth?
Of course it does.
So it's three-dimensional then.
Exactly.
Yeah.
Exactly.
Just because they ignore one aspect of a dimension doesn't make it two-dimensional. It just means they're ignoring the one aspect of the dimension.
Yeah. If you face the surface of a sphere towards it, you're going to have the apex of the sphere closer to you than the sides of the surface of the sphere. Do you know what I mean? So it's still 3D.
Exactly. Hey, Skeptic936, great to see you, mate. I'm glad you could make it. Thank you for coming.
So here, I have again wrapped the Mercator projection with the circles of equal altitude back around the globe. So we're reverse engineering it here. And as expected, we've got some teardrop shapes going on. So I've gone ahead and drawn the celestial objects in AutoCAD. They're obviously not to scale, they're just to give us some angles to work with. So you've got one here right above this GP point, and then one here right above this GP point. Okay, so from the crossing point here, I've drawn a line up to the celestial object, and I've drawn an arc following the surface of the Earth from the GP position to the point where they cross. Now, if you remember earlier, this circle, when we drew it on the Mercator projection,
Sean, you can review all you want. The more you review it, the more dumber you make yourself. So don't worry.
And you already told us that earlier on, so
Yeah.
you just tried a bit of them.
You know why you make yourself dumber? Because you show you don't know anything. Remember how much times this guy's reviewed my videos, and every time he says something, the next sentence he reviews, he literally makes my point.
He does.
Yeah. That's how dumb this guy is. He watches it live, and he reviews it, and ends up making my point. Hi, Habanero. Good to see you. Thank you for coming. Yeah, the surface is a baseline, so it would be horizontal.
was 2,000 miles in radius. So let's just go and interrogate this arc and see what the arc length is now. And luckily we can do that by clicking. You can see what's highlighted.
Yeah, I want to know how you can get a tangent to a horizontal apparent position. Because what's a tangent? It's a straight line touching at a curve. First of all, a horizon is horizontal. And second of all, it's only optical. It's not actual. So how would you get a tangent to it? How's it going here? 85 votes so far. Celestial navigation is based on horizontal reference. Yes, 74%, and no 15%, and no idea 11%. It's good to see there's 11% that is honest with himself, that they say they don't know, and 74% that do actually know, yes, how it works, and then just 15% that lies. Yeah, very simple stuff. It's only you, 40 to 60 flat earthers, that know these things. Knows what things? What's he talking about?
Goodness knows.
The arc. We scroll down here to the properties, and the arc length is 1,750 miles. So quite significantly shorter than the 2,000 miles
Exactly.
that it was drawn on the Mercator projection.
Yeah, you know why it does that? because when they drew it on the Mercator map and they had to place it now on a sphere, like they believe it to be, that radius distance changes. And because it's not circular, it's a teardrop, it changes the output. And that's what gives that idiotic data.
So let's go and have a look at the other arc. So selecting the arc, scroll down, arc length, 1415 miles, so even shorter. So almost 600 miles shorter than the circle radius that we drew on the Mercator projection.
Wow, hectic.
So I keep saying that if we're living on a globe, then the geometry should also work on a globe. And I think it's a misconception that people have, is that a circle of equal altitude on the globe will actually look like this. However, in reality, the red teardrop shapes shown here are directly interpolated from the flat Mercator projection. And if you look at the locations that these red lines pass through on the Earth, you look at the continents and the land features, you'll see that...
Sean, he says, the reason he does that is because he's taken off a flat projection, drawing on it and then wrapping it around back around the globe. Very dishonest, epic fail. I dumped this when it was first presented. Sean, you do know you just debunked yourself there and shown you have absolutely no idea what's going on. You know why? Because navigation is done on maps, not on spheres. Do you understand this? When you do navigation, you draw out on a map. You don't draw it out on a sphere like Proto did. The dishonesty is drawing it out on a sphere instead of a map. Because maps are two-dimensional. It's a coordinate system.
matches exactly the circles on the Mercator projection map. So there's absolutely no possible way you can triangulate your position on a globe that has been transposed from a flat Mercator map.
So I want any globe in here to show us where the Navy uses globes to draw their circles of equal altitude on, please. Show us a globe that they have sitting around where they draw their circles equal altitude on. I'll wait. Because I can guarantee you they use maps like the Mercator map. Maybe ask Arctic Reflections what map he uses.
Sean, you debunked yourself. He's saying that that line's getting old. He can talk. He comes in with the same thing every time.
Yeah. Good baboons. He's using CGI to debunk the globe. Oh wow.
So this then begs the question, why are we even drawing circles on the Mercator projection? A circle just seems arbitrary, considering it translates to a non-symmetrical shape on a globe with no common radius value. If we are truly living on a globe, then we need to be able to triangulate our position on a globe, and it just doesn't work.
I don't need to ask Arctic Reflections because he's already told me, Dustin Bones. That's why I'm asking you guys to ask him, because his answer validates me and literally throws your guys' argument in the water. Sean.
The reason we use a flat map, and it works every time, and has done for the last couple of 100 years, is because the Earth is flat.
Amen. There we go.
Okay, so to briefly touch on what the guys over at Flat Earth Debate have been saying, we're going to use the exact same examples of the GP positions here. I'm going to look at it from an orthographic view. Okay, if we're standing here on the Earth, this is the angle to the celestial body. Let's take a line from our position representing the horizon. The angle formed here is definitely not 90 degrees. And even at the position where...
Yeah, Rob, the reason that's not 90 is because they take the 90 to the center of Earth. That's why they duplicate the angle to get it. And that's why it's dishonest as well. Yes, Arctic Reflections would agree with me, Dustin Bones. They use the Mercator map, not a sphere. He doesn't sit with a sphere globe when navigating. They use maps, two-dimensional maps.
Where it meets the Earth. You can't have a 90-degree angle to a curved surface.
Nope.
And AutoCAD will actually verify this.
Yep.
Because if I choose the angular dimension command and I pick this line and this line, it will give me an angle between them.
Yep.
If I try to pick this line and this arc,
It won't give an angle.
it says here, object selected is not a line.
Hey, to Ellen, good to see you. Thank you for coming. Oh, man.
Because it's not.
And we get the people always telling us, oh, yeah, oh, you can have an angle from a curved surface. Look, let me draw it on a two-dimensional paper. Yeah, it's like, let's do a new one. Okay. This is your sphere, guys. Now you draw your horizontal or whatever there, and you're trying to say, oh, I measured now, and you're saying it's got a 90-degree angle like that because it's showing straight up. How do you get that 90-degree angle? Oh, because you're duplicating. You're literally duplicating that angle to the center of your globe, and that's how you just duplicate another 90. That's dishonest because you literally just duplicated it. You haven't measured it here, you measured it over a horizontal plane. Horizontal plane, horizontal plane, horizontal plane. I don't know, must I repeat it? Horizontal plane. Now, let's take that duplication angle away and try and draw that as a horizontal. Oh wait, you can't draw it as a horizontal because it's got a new zenith. So you literally have to throw your arc away to duplicate it, to give it a new zenith angle for your co-altitude angle to exist.
Yeah. Sean reckons the guy didn't join the line in the curve. That's why he didn't get the reading that he was looking for. No, that's not it. I think he knows what he's doing, Sean.
Sean, it literally, you can try this for yourself on AutoCAD. It doesn't matter how much times you try. It's not an angle. An angle is two straight lines, rays, meeting at a vertex. If you don't have a straight line, it won't give you an angle.
So it will just not give me an angle. And why would it? How could it? The angle will be different at every single point on that arc.
Exactly.
So the question is, to the people who believe we live on a globe, 1, where are you getting your 90 degrees?
Horizontal.
2, where are you getting your straight line to form the 90 degrees? And 3, where are you getting your circle of equal altitude? Because from what I'm seeing, none of them are available to us using a sphere.
Again, Sean, every single point on that curve would have a different angular reading. You know why that is? Because it's the distance from the lines to each other, which gives the curve angle measurement. Man, these guys are morons.
It's unbelievable.
Yeah, it's crazy. Okay, so that was with Rob Durham. Are you guys enjoying this so far? I hope so.
Good.
Because now we're going to take on where he's trying to give an argument to Brian's logic. I did ask Brian's logic if he wanted to come on tonight, if he can make it, but he's probably going to be on Ballbusters.
Yeah, he'll be in QE, won't he?
Yeah. Yeah, tell us how we don't understand simple geometry, Sean. You know when you say that, it's just your projection.
Yeah.
Bobby Street Designs, I'm glad you're enjoying it, mate. Thank you all for coming again. I really appreciate all your support. You guys are awesome.
I mean, it's obvious. You take on that curved line, like John, if you take one step from your position, the angle is different. It's not the same angle as the step before.
Yeah.
In my previous video, I responded to Flat Earther 10th Man and his insistence that I debunk his cited sources. I oblige.
3CPL, thank you for your say. So why can't any flat earthers do celestial navigation? By default, everybody's a flat earther, so by default, everybody does celestial navigation on a flat surface. Your elevation angle to take the measurement, horizontal.
Yeah.
And showed that all of his sources actually disagree with him.
Okay, they are not negotiable. Elevation angle measurements, end of the debate, since it can never be achieved from a curved baseline, which is a truth. 10th adds, he needs to debunk your cited sources. Celestial navigation is what is against our reading in context of those sources, okay?
And in fact, the panel's entire sextant narrative is built on a curved adjacent straw man resting on an incorrect redefinition of elevation angles.
Is that so? The upwards angle from the horizontal to a line of sight from the observer to some point of interest. If the angle goes downwards, it's called an angle of depression. Yeah, angle of depression, angle of elevation, based on the horizontal reference. Note the Earth's surface is not a line in this angle. Yeah, you guys create a horizontal reference, hence why you have elevation angle. Because the angle is based off of a horizontal reference of elevation.
That is contradicted by those same sources. In short, their citation-based flat Earth celestial navigation argument is just a massive exercise in confirmation bias.
Is that so? Just like you trying to tell us now it's got nothing to do with Earth. Yeah, I'm going to quickly go to something. Going to my channel quickly. Videos. Or is it a short? I'm not sure. I think it was a short I had on. It was one of these. Let's first try this one.
See, we don't care about the Earth.
Oh yeah, there we go.
We care about from the horizontal to the star. That's what we care about. We don't give a shit about the Earth. The only reason we use the Earth is to find out where the horizon is and then create the horizontal plane based on the dip angle that you're looking at it at. See, we don't care about the Earth. The only reason we use the Earth. See, we don't care about the Earth. The only reason we use the Earth, we care about from the horizontal.
Visible through the telescope. The movable arm, which is called the index, and the attached mirror are rotated so that the image of the sun is reflected through the darkened glass onto the half-silvered mirror.
Yeah, you guys listen to that? We don't care about the Earth. The only reason we use the Earth, yeah, to find where the horizon is. Congratulations. Now why is it? Come on. Now it's buffering. So Sean, we're literally having you live on stream contradicting yourself and debunking your own argument. So congratulations. Okay, so let's try and listen again. Then we're going to listen to... No, let's listen to this one quickly first. This one is also quite funny.
Great.
Yeah,
so
but
you
either
level.
We're talking celestial
You can
navigation.
take a line to the horizon and do a elevation correction.
We're sailing on surface of Earth on water, right? And we're trying to work out how far away we are and where we are by using angle measurements to celestial bodies. Why do you think you have to use dip correction to get that baseline down to the surface of Earth? Because it's only way
If you're at the horizon, it's because you're above the horizon.
horizon by your observer, right?
Yeah, I mean that's an error. You could. It's up to you whether that error matters.
And that's
But if you want to get it perfect, yeah, you got to correct for that. Sure.
You've got to correct for it, yeah. Why do you think you have to correct for it and get it down to what?
Same place as last one where it's buffering. Exactly the same place. Not dodgy at all. Okay, anyway, you got the gist of it, guys. That's how it works. Hi, Daystar, good to see you. Thanks for coming. Sean, don't care about the Earth. Yeah, Wally says we only use the Earth to care about the horizon. Celestial navigation, you know, celestial navigation. requires a horizontal reference, which means using the horizon. So when you're using a nautical sextant, you're using the horizon to have on your base horizontal. Simple as that. And yeah, the reason you have dip correction is because your eyes are not embedded in the ground. You standing, usually on a boat or something, means you have elevation. So you need to correct for it so you have it 100% parallel to the surface of the horizon of the earth. So you're moving that elevation angle to the ground, so you have a GP horizontal plane. So your GP horizontal plane has a circle of equal altitude to the GP of the star. Hence, if you measure a star that has a GP 2,000 miles away from you, that means you're on the same horizontal plane. Flat Earth, guys. Very simple stuff.
But that was just the first half of that video. I went on to do something they've never done in their 2 years of constant chanting about celestial navigation. I actually demonstrated a position fix.
Destock, Polaris is not visible from South Africa. No shit, Sherlock.
Yeah, definitely not.
Flatwood has no valid reason for this. Is that so? What does this say? Destock, tell me, what is this telling you? 5,400 nautical miles away is equator, correct? From Polaris. Which would be 0 degrees, correct? Now, I am past that measurement. So, in other words, I cannot see anything because it's too damn far away to see. The angle is too acute. So, go take your lies and bullshit somewhere else.
It's like I don't see the Southern Cross as well as like you can, but it doesn't mean to say I can't talk about it.
Yeah. Yeah, bubble sextants exist, Turin. And guess what bubble sextants do? Create a parallel horizontal to the horizon. Should I draw that out now too for you, idiots? This would be the ocean, horizontal. This would be a plane flying above. It needs to create a horizontal baseline parallel to the horizon. You understand? That's what a bubble sextant does. So it literally takes the duplication of the horizon to you. So it's like bringing down the airplane to the ground. You're welcome.
Including showing how the underlying geometry is entirely globe-based.
Is that so?
And while Tent and others did react to my video in a recent Flat Earth debate show, it was limited to complaining about my handling of their citations, completely avoiding any discussion of the demonstration that drove the final nail in the coffin of their narrative.
Okay, guys, I have to point something out. He's busy standing on the beach or somewhere, correct? He's looking out horizontally, vertically, which is of a horizontal, correct? To get his measurement. I think we've done this many times, but we can do it again. How a sextant works. We did this the other night, actually. The sextant principle. Okay, I'm just going to quickly show this one. This is very simple. This is practically what he did, guys.
To measure the angular distance between the sun and the horizon, a sextant is held to the eye so that the horizon is visible through the telescope. The movable arm, which is called the index, and the attached mirror are rotated so that the image of the sun is reflected through the darkened glass onto the half-silvered mirror. The half-silvered mirror is level with the horizon. The angle is read on the limb, or calibrated arc.
The angle is level to the horizon. Oh, Uh-oh. And how far can a horizon be, apparently? And how far is a new zenith tangent on a globe? You guys don't think, do you? Congratulations. He literally showing you actual demonstrational footage of him standing on a horizontal, taking a horizontal angular measurement, and then says it's globe. This is how idiotic these people are. This is how stupid you morons are. I'm saying it straight out. You are a idiot.
Perhaps they would have gotten to that eventually, but show host Nathan Oakley made it very clear he would not link, show, or review.
I just reviewed it because it's showing you how stupid it is. So,
Dude, but stop brainwashing people. Your brain needs washing with all that crap that's in it about globes and stuff. Okay?
yeah,
Okay.
exactly, Derek. Done it more times than I can count. Exactly. Every time they pick up a sextant, they are literally proving flat Earth. And I highly stand by that claim. It's proving flat Earth. Because the principle of a sextant is based on the, what's that word? Succession angles. You know what succession angles means? They have to be parallel to one another to work. Hence why you bring the celestial body down to the horizon, which is parallel. It's perpendicular to the guy standing to a parallel. An elevation angle isn't a horizontal. Oh. Maybe they can say it to you instead of bring up a definition. Elevation angle definition. Oh, an angle of elevation involves 4 items. Horizontal. Oh shit, what's going on there? Let's look at this. Remember what Sean Hawkins says? Sean Hawkins says isn't horizontal measurement. Let's see what... Oh, okay, let's pause it. Okay, angles of elevation are angles above the horizontal.
Minnie, shut up! Sorry, somebody was at the door, so she's barking.
Okay, imagine looking up from the ground level towards the top of a mountain. Okay. There's a person standing, and the person is looking out towards a top of a mountain, guys. Remember, the angle of elevation are angles above the horizontal. Elevation angle. So the base is a horizontal, guys. I'm definitely not going to just try and download this 43-second video. Hey, Virendu Max, thank you for coming. Glad you could make it. My daughter actually asked me today if she wants a dog again. So I might have to get one. Oh, do I really have to download this? Download. Okay. And now you want to work now on downloading, okay? So the angle of that an observer would raise his or her line of sight above the horizontal, hence keyword horizontal, line in order to see an object is the angle of elevation. 2 straight lines meeting at a vertex. The elevation angle to the object. The succession angle. It's a mirrored angle. That's how a sextant works, you morons. Tell me where there's the curve, Sean. Tell me where there's no horizontal in an elevation effing angle, Sean. Sorry, I'm getting actually quite irritated now with him. because
I know. He's just saying the same thing all the time, and you know, I've been quite nice and not timed him out. You know what I mean? But there you go.
Hey, Maker Ray, thank you for coming. Maker Ray asks, serious question. I hope you have an actual answer for. What is the dip correction for in celestial navigation if the horizon is the horizontal? It's because your elevation angle is not, I repeat, is not situated at the feet, the surface. So you have to do the dip correction to take the elevation angle to the ground to finalize your triangle, because your GP has to have a circle of equal altitude to the GP of the star, a triangle, the same horizontal plane, aka why you guys have a so-called equatorial plane. So, an angle of elevation involves 4 items. Object, congratulations. Horizontal, which Sean says is not involved. And an observer, congratulations. And a line of sight. The hypotenuse is the line of sight, guys. So, what do I show here again with the line of sight? The hypotenuse is the line of sight. So, the distance based upon the horizontal elevation angle gives your what again? Your angle measurement. C3PL says there's no triangle. What are you smoking? Hey Daz Studio, good to see you. Thank you for coming. 3CP hole. I think you know that stuff you're sticking in the hole? It's going in the wrong hole. Yeah. You might need glasses. What's a triangle? 3 angles with an internal sum of 180 degrees. Correct? So he's measuring 33 degrees and 90. What would be the other angle? C3? Huh? Come on. 90 plus 33, then minus 180 will give you that angle. Internal sum is 180 degrees. There we go. Yeah, Sean. We understand you are too dumb to understand. You've debunked yourself live already by just having a short play where you say we don't care about the earth, but we use the earth.
I'm sure your 9 viewers will enjoy the gravy.
Yeah, he's 9 viewers, exactly. Brilliant. Okay, so let's get on to Proto.
Any part of my video, saying I could only make my case live on the show. But
angle measurements don't have a hypotenuse. I'm sorry, give me 2 seconds.
I thought hypotenuse was to do with angles.
What is the function of a hypoto? In geometry, a hypotenuse is the longest side of a right angle triangle. The side opposite to the right angle. And celestial navigation uses what? A right angle triangle, correct? So, hypotenuse, Sean, horizontal. It's a 90 degree, giving the hypotenuse, which would be the angular measurement. Because what? Remember when we say a triangle has an internal sum of 180 degrees?
Yeah.
That is an angle, that is an angle, and that is an angle. Without the hypotenuse, you cannot have an angle or an angle.
No. You've just got 2 lines perpendicular to each other.
Yeah. This is why I laugh at these guys, because they literally, if you had to go into a, I don't know, primary school math class, geometry, and tell them hypotenuse has nothing to do with an angle, they're going to laugh you out of the class.
Then had me banned from his server, making that impossible. And can you really blame him, considering how devastating that video is to their claims?
There's nothing devastating on this claim. Your video you just showed literally proves a flat earth, Proto. Literally.
Jeff Gosshead, very dumb, very dumb.
Woo-wee.
But at least one panel member was brave enough to provide some feedback. Brian's Logic commented directly to my YouTube channel, rejecting my demonstration because I had not drawn my circles of equal altitude on a flat surface.
Oh, so Brian's Logic also picked it up. Congratulations. Yeah, you didn't. How do navigations work again? On maps, two-dimensional maps, not globes. Because if you did it the way it's supposed to be done, it wouldn't work, would it?
The fact that they nonetheless intersected at the correct latitude-longitude coordinate.
Whoa, 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 whoa. Is that the video we just watched? Or is this, I mean, it was 3 lines and it created a triangle, correct?
Yeah.
I just want to go back and see. I'm going to take a screenshot here quickly. And I'm going to place it in Paint Globus for you. Because you love paint so much. And then I'm going to go open the video where he showed the celestial navigation.
In this video, I will be this little triangular looking thing. It's not quite a trapezition. To what the actual answer is.
Ha! Okay. This is the video we just watched, correct?
Yeah.
Wow. Does that look the same to you? The positions are not even the same. This is where his triangle was. And this is what he's pinpointing. Here. That's his new location there. That's the location there. 47 degrees 93. 42 87. So he's got different measurements to the same answers. Or did I miss something? Maybe he's got another video. Let's quickly go check. Proto. Potot. Potot. I'm going to call him Potato Head from now on. Potato Head. Okay, he's got 3 videos. Okay, so it must be this one then. Is this the one he's saying they don't want to show? Okay. Let's quickly download this. Hey, Flat Alex Anonymous, you still haven't answered me. When are you coming on to my show to debate? He says horizontal has nothing to do with the surface. You can get the horizontal from the top of a mountain. You know what a horizon means, Flat Alex? Let that sink in. Okay, so this is that video. Oh, response to, okay, it's a long one. But let's see, maybe he shows it, doing it. We can actually go through this one another time, because I see it's quite long. Yeah, oh, yeah, is he doing it? Or is he done another measurement?
Learn from just reading citations. Often, the full understanding of a process only emerges from actually doing the thing, and celestial navigation is very much like that. That is why I keep encouraging 10th Man and the rest of the Fed panel to actually take that.
It's FED panel, not Fed panel.
Next step. Otherwise, you just trapped yourself in a loop of arguing definitions and citations.
Hey, Danish Brug. Yeah, the reason you don't like the things, Globers hate definitions and citations, because it usually shows them contradicting their globe.
Yeah, they have to change the definition of a word to suit that. Right.
Exactly.
So how can we break out of this citation loop to actually test our claims? how can we explore what the real underlying geometry of celestial navigation is? Here's a crazy idea. We could actually do some.
While he's showing on screen how he's literally creating a horizontal parallel to the horizon. Congratulations, Proto. So debunking a globe by picking up a sextant. Awesome.
And luckily, I did just that for the college seminar I recently taught. We worked through some Meridian Passage sun sites I shot along the Baltic Sea, and also some nautical twilight star sites I took closer to home. So buckle up, we are going to actually do this stuff for real.
Hey, John Edwards, good to see you. Thank you for coming. Glad you could make it.
It starts with a sextant site of Saturn at 24 degrees, 7.0 arc minutes. Followed by Shadar at 39 degrees, 36.2 arc minutes.
Congratulations.
And finally, Altair at 55 degrees, 33.8 arc minutes.
Well done. And all these were triangles on the same horizontal GP planes. Congratulations. So, flat then.
Of course, we have to do the corrections on these sextant readings to get the observed altitude, and also look up the latitude, longitude coordinates of each celestial body's GP in the nautical almanac.
Yeah, because GPs need to line to your horizontal position GP as well. Because you have to be on the same what? Equatorial plane. Otherwise, the circle of equal altitude will not work. Hence why you have things like height of eye correction, your so-called dip correction. And yeah, you have a bit of refraction because it's an optical measurement. And then you have corrections on your sextant because it has what you call corrections to be made because it's a mechanical device. Congratulations. Now, knowing that you have a coordinate system to work off of, how is that globe based? Oh wait, it's not. It's a coordinate system.
Based on the time we took each site. We do that first for Saturn,
Congratulations.
then Shadar,
Congratulations.
and finally Altair.
Wow. Okay, congratulations. All showing quite a distance on the same equatorial plane. So in other words, a horizontal plane of 2,069.3 nautical miles. That means the GP, let's just remove all this again. That means the GP from the star, draw star, is at the same GP as the man standing here. So let's go and draw to see what's going on. 90 degrees, 90 degrees. Now you brought down the angle measurement to have an elevation angle to the ground. So the same GP. Do you understand this? Your co-altitude angle is based on your apparent angle to the star, which is 90 degrees on the same plane as your 90 degrees. Get it yet? Flataholic says that is nonsense. The purpose of the dip correction is to establish the horizontal. You establish your horizontal before you do dip correction. Shows you don't understand how a sextant works, mate. You first measure, then you do correction. Not do correction, then do the measurement. Ouch. So when are you going to come on my show, Flataholics? Hey, Eric Duke, Colvin Bay, good to see you. Thank you for coming. We're not showing any globe, Eric. We're showing flat Earth. Yeah. You see this on screen here? That is flat Earth, not globe.
I take it his name's a
Eric,
derivative of Eric DeBay's.
yeah, probably, maybe.
Yeah, Eric
That
DeCole
gives us all
Yeah, I think so.
the information we need to draw our circles of equal altitude.
Yeah.
Now, of course, to draw the circles and have them intersect at the correct latitude, longitude coordinates, it has to be done on something the same shape as the Earth on which...
False. False, false, false. Protothad, how do the navigators do their circles equal altitude? Drawing circle of equal altitude. Oh, Bob the science guy. Oh, Bob the coward guy, more like it, but yeah. Maybe we can get to.
He's quite a good runner for his age, isn't he?
Yeah. He does run a lot, so.
Yeah, he does. Yeah. Oh, John, piss off.
I'm waiting for them to. I'm trying to look for the right videos where they actually show us them doing it on a map. Meridian passages. Let's go to Google roll. It's gonna be much easier. Circle of equal altitude celestial navigation mapping. Okay, this is equal altitude parallels, longitude, eastern Greenwich. There we go. Is this a globe? Does this look like a sphere that they're using? Or is this a horizontal, two-dimensional paper with a coordinate system on it?
I choose the law.
Discovery of the circle of equal altitude, a new and accurate method of finding a ship's position at sea by projection of the Mercator's chart. So this is based on the Mercator. Sorry, do they draw it on a globe, Protothad, or do they draw it on a map? Usually like the Mercator map. It's drawn on a bloody two-dimensional map, guys. Look here, even the other show it's not. Look at that. They're showing you it wouldn't work out. Thank you very much.
The angles were obtained, which is why we are doing this on a globe. If we tried to draw these circles as actual circles on a flat world map, they would fail to intersect correctly due to the distance distortions that will always result when projecting a globe to flat or vice versa.
And yet all the navigations ever done are shown to be on maps like the Mercator map. So Protothad, maybe you can get yourself a lot of money by getting contracts to going to all the navies in the world and selling them this globe. Saying, heck, you don't need a map. Throw your maps away. Use this globe. Draw it on it. Because that's practically what he's saying. Is it not? That's how I understand it. He says they don't draw on maps, they draw on globes. Which is bullshit, guys. It's nonsense. It's idiotic. Navigators do not walk around with globes on ships and draw on globes. They draw on Mercator maps. Proto said, exactly. And sorry, trolls in chat, I don't give a damn what your opinion is. It's bloody fact. No one draws on globe spheres. Ever. Because, yeah. It's insane.
So how do we go about drawing a circle of the appropriate size on a globe? It's quite easy, actually. As you know, the distance from the observer to the GP is simply the co-altitude times 60 nautical miles per degree.
Yeah, congratulations. So, that measurement. Oh, what's a 90 degree again, Protothad? Hey, Debatable D. How you doing? And Danish Boog. Building planes are in 2-dimensional, but they represent 3D. Yeah, building a plane is not celestial navigation.
Yeah.
You ever heard of false equivalence? Yeah. So, 60 nautical miles per degree. Congratulations. So, what is this based off of? Protothread? How do you get that 45 degrees? Oh wait, would that be what we've been showing all this time? There's the 45 degree. So 45 degrees would show, based on this one, 2,700 nautical miles, correct? What's that? 2,700 nautical miles. Oh wow. So he has exactly the same distance as what I showed on a horizontal line. Weird how that works, correct? Maybe because it's bloody based on a 90 degree angle, which means it's a perpendicular to a horizontal. Congratulations. This that you have on screen now, Protothad, is you showing it is based on a flat earth. Multiplying an angle by a distance gives you an arc length. Yeah, so celestial sphere being duplicated to your globe. Yeah, congratulations.
Plain truth. Imagine being lost in the middle of nowhere with a toy globe and a pen.
Well, that's what Protothad thinks happens.
Absolutely.
That's what he thinks.
This is an application of the arc length formula and gives you a curving partial circumference, a segment of a great circle route over the surface of the Earth. Since the equator is a...
PT, I don't need to because he's literally doing it for us. He's doing a practical demo for us on screen now.
But how many demos have you done? How many videos of demos have you got? Plenty.
I don't understand how it's so difficult to understand. This demo he's doing is taking the measurements from a flat horizontal baseline, a plane, and just giving it a duplication to say it's on a sphere.
Right.
This arc length, guys, is based on perspective. It's a celestial sphere arc length, which is just your field of view to the star. The actual apparent angle measurement is done from a horizontal baseline, which is literally proving right now because of 90 degree base.
great circle route with every degree of longitude equaling 60 nautical miles, we can use that as a scale to set the span of our drafting compass.
Congratulations.
So, if we have a co-altitude of 45 degrees, with a distance to the GP of 2,700 nautical miles.
Again, you see that arc distance is put there? Stick it up in the sky. It would give exactly the same arc length, correct? Let's do it this way. Oh, man. This is actually frustrating tonight, guys.
Mm-hmm. It does. It gets exhausting, doesn't it?
Okay, let's just say, for instance, that's an arc length. Obviously, okay, oh, man. It's actually difficult to draw it like this. Okay, let's do it this way. This is a arc length, okay? Now, what happens when you're going to duplicate it? You're just taking that angle arc measurement and you're duplicating it to the center. This is the center. I'm standing and I'm looking at a star. Let's, for instance, let's put a star here. Whatever. Star can sit here. That's the star. I am perpendicular. This is me standing here. Let's just put me. This is me. I'm purple. Whatever. Doesn't matter. And I am now looking out to the star. So, I'm reading an angle measurement to the star. Let's just say, for Pete's sake, that is 45 degrees, like he said. Now, we've done our dip corrections, everything, so we can go to the same plane. What is this? This is a 90-degree angle. Correct? This would be a 45-degree angle. So, how do we know the co-altitude angle? Because we've measured 45 degrees to the star, it's based on a 90. Remember, I also have a 90 degrees on the same equatorial plane, the same horizontal. We know the internal sum of a triangle is 180 degrees. So, that angle is 45 degrees. Correct? 45 plus 45 plus 90, 180. So what is your co-altitude angle? 45 degrees. How can you work that out? Let's take 90, which is measured, minus 45, which would equals 45. Now, you know you need to have it in nautical miles. We times it by 60 because of arc minutes, which gives our distance of 2,700 nautical miles. Okay. Now, tell me where I had a sphere here. PJ, did you see me use a sphere anywhere?
I can't see a sphere anywhere on the screen in a minute.
No, you got a circle, but that circle is not the sphere surface.
No.
So, this arc you are representing here is the celestial sphere, guys, based from a horizontal plane. Now, you got the horizontal plane, you got the celestial sphere. The globe literally takes this arc length measured here, that would be the 2,700 nautical miles, and they duplicate it to say the surface of the earth. They're taking the celestial sphere and calling this celestial sphere the surface of the earth, because they just literally duplicate it to the center of the sphere. That's it. It's as simple as that. The math is done flat. The measurement is done flat. The consideration is based to be belief on a sphere. They duplicate the angle and move the celestial sphere arc, which is the true distance. Remember, the hypotenuse distance relationship to the horizontal gives your arc distance. So they take that arc distance and they put it to say it's the ground. Simple as that.
We can simply put one point of our drafting compass on the 0 longitude point on the equator and adjust until the other point is on 45 degrees longitude. And there you go. The only thing left is to then center the drafting compass on the latitude longitude coordinates of the GP and draw the circle. So doing that with Altair, we size it to about 34.5 degrees.
Flat Earth Holics Anonymous. Mercator is a globe projection. No shit. It's a two-dimensional map. They draw on two-dimensional maps. They don't draw on physical globes. Are you too stupid to understand this? Navigators do not drive around or sail their boats with globes around in their in the bay on the trying to say, hey, bring me my globe so I can navigate quickly. They use a map, like the Mercator map, which is two-dimensional. There's a reason he's drawing it on the circle, is because he's trying to be dishonest, because remember Rob Durham's video we showed earlier? Yeah, that's the reason.
No, Simon, you can't. You definitely can't.
Exactly, Simon.
Center it on about 9 degrees north and 80.5 degrees west, and draw.
Congratulations. Drawing a circle on a sphere.
Notice there is no use of the Haversine formula. No messy math of any kind. Notice there is no use of the Haversine formula. No messy math of any kind.
Yeah, there's no use of the Haversine formula. You know why? Because it's not a globe.
Rudolph asking if you want a globe or guest.
Does Ruev want to come in?
I don't know. He's just asking if you want a globe or guest. I don't know if he means himself or...
He does probably mean himself.
Well, there you go.
There we go, Ruev. Stream's open for you, mate.
We just size the drafting compass directly to the co-altitude angle and draw. Done. We can do that because we are simply recreating the geometry of these circles of equal altitude as they are in the real world.
No, you're simply taking the celestial sphere and drawing it on your physical globe. That's it. Hey, Drummer, thank you for coming. Good to see you. Hey, we got Ruev in.
Good morning, Plateau.
How's it going?
Lovely.
That's good. Maybe I can put you a bit
So
louder.
you're looking at Proto's video,
Yeah.
and I'm curious, like, you've been asked probably 1,000 times by various people to show a worked example of celestial navigation working on flat Earth.
I just
Why won't you
explained.
do it?
I just showed you on Paint like 2 minutes ago.
No,
you
a
get the
worked
angle?
position fix.
That is a worked position fix. I gave you a
Did you
distance.
take angles and end up with a position?
If we measure 45 degrees and it gives me a distance to the GP of 2,700 nautical miles, that is one fix, correct?
No. What are the latitude and longitude coordinates of that fix? Where are you?
What do you mean?
Let's say I give you 3 angles. Can you go through an example of celestial navigation and end up with a position on Earth for where you are? Can you do that?
If I use the nautical almanac, yes, because it gives you your...
Okay, let's do it.
But I'm saying it gives you because you got the GP of the star, correct?
Yeah, we can
Great,
get the
so
GP of the
it's...
star.
Wait,
Yep.
so it gives you your... what is the word? Because it's a flippin' grid system. The Cartesian, it's a coordinate system.
Right.
So if it
But
gives
if I
you...
give you 3 angles, can you tell me where they were made from?
I don't understand what you mean. If you give me 3 angles, can I tell where they're made from?
What does celestial navigation do in reality, right? It tells you where you are, right? You take angles to stars, and then you go through a process to find out where you are.
In the
Can
nautical
you do
almanac.
that process?
In the nautical almanac.
That will work out the GPs, yes.
So usually
But
like
there
to
are other steps.
usually like to Aries or whatever. So let's
To-
say
to whatever the
let's
stars
say
are,
like he's doing now, where he has his 3 stars, correct? Where's his 3?
Right, and he gets a position fixed, right?
He gets all
And
3
it was
position fixed.
Lake Superior time.
Like Shredder, he got a SHA, he's got his Aries, HA, he's got Jet. That's from the Nautical Almanac.
Right.
That gives his, and then
Can
he
you
gives,
turn angles into a position?
yes, if you got the Nautical Almanac, because it gives you the GP.
Right. Yep.
So
So you got the GPs, and then what?
you're missing the point now. You got the GP, and because you got the GP, which gives your position to the ground position, because you know if you're 3,000 nautical miles away from, let's say, Shredder,
Right.
you know you have a circle of equal altitude from that position.
Okay. Can
Like-
you draw one of those circles
On what?
on a map? Like,
Yes, because it's a circle.
okay, let's do it.
Which map you want me to use?
Whatever map you think works on a flat Earth.
All maps work on a flat Earth. Must I use a Mercator map?
And you use a Mercator. Draw a circle on a Mercator map.
Don't know if you have a high resolution though. How are we going to do this? Do you have a Mercator map I can use?
Sure. Whatever map you think works.
Doesn't matter. Gleason doesn't matter because it's just
Yeah.
coordinate system. Heck, we can even use Google Earth if you wanted to.
Google Earth uses a sphere, so
No, Google
you wanna
Earth
use that
uses.
and welcome to the globe.
No, Google Earth doesn't use a sphere. Google
Yes,
Earth
it does.
uses elevation angles from 0 to 0.
No, Google Earth uses the Vincenti formula to work out the distance between point A and point B.
The
Right,
measurements
if you
are
want to use
done
Vincenti,
flat.
then welcome to the globe.
No, they use the Vincenti formula is based from flat measurements, just like what
No,
I just
the Vincenti
explained.
formula is a formula just like the Haversine formula that tells you the
Comes
distance
after-
between
yeah.
2 points on a sphere or an oblate spheroid.
Yeah,
Doesn't use a flat
but
Earth.
the measurements come from the horizontal. You do know elevation angles on Google Earth literally show 0 right around, correct?
That's right. If I'm at point A on a surface and I want to find the distance to point B in order to draw a circle, what formula are you going to use? If you're using Vincenti or Haversine, then welcome
I'm not
to the
using
globe.
Vincenti or
If you use
Haversine.
something else, I would love to see it.
You use a coordinate system. You don't really need to know Haversine or Vincenti. Remember,
Then
let's take the math I've literally shown on screen, the 90 degrees. Does that math work out to give you a distance to the GP? No, listen.
I'm not interested.
I'm going to explain it to you. You want me to explain it to you? Let's say
No, I don't need an
I
explanation.
measure-
I need
I
an
got-
example,
I-
a worked example of you doing it.
I'm literally explaining it to you. Let's say
I don't need an explanation. Sorry.
co-altitude angle is 50 degrees, just like he's given there, correct? Of Shredder.
I don't need it. I don't need to be
We
explained
have
to
the
flat
co.
Earth. I
We
need
have.
you to show
I'm
how
showing
it
you.
works
I'm showing
on a flat
you.
Earth.
I'm showing you now. We got a co-altitude angle of 50 degrees to the star, correct? Now, let's
Sure.
work it out to get the distance to us, because that's what you're wanting
Sure,
to know.
3,000
To know the distance.
3,000 nautical miles. Draw a circle on
Okay.
a map. 3,027 nautical miles in radius. Please do that.
Check here. Let's say we measured a co-altitude angle. We've already got the 50 degrees here.
Mhm.
So we've already measured the actual angle. Now, 90 minus, well, it's going to be 40 because we're giving a co-altitude angle of 50, correct? Which will equal?
Just draw the circle of 3,027 nautical
So
miles.
it's 50 times 60 to give the nautical miles, which gives what? What's 50 times 60?
3,027.4. We had the number on the screen.
Great.
Just
So
draw
you just
that
asked the
circle on a
distance.
map.
You just asked the distance. You just asked the distance, correct? So was my
Yeah,
distance
it was on the
correct?
screen previously, right? 3,027.4 nautical miles. Go back to the other screen.
There we go. So, did my math give the same distance to the GP of the star?
Yeah, look.
Listen, did my math... You're not answering me.
It's 3,000 nautical miles. We
Congratulations.
agreed it's 3,000 nautical miles.
Congratulations.
Draw that
Congratulations.
on a map.
Congratulations. Now,
Yeah.
did I get that measurement from a curved surface or a flat surface?
It's from a curved surface because it only
sorry?
works on a curved surface.
No.
And you won't
Sorry.
draw this circle on a
Sorry,
map
listen.
because you're
Can you
just stuck
stop
giving
straw manning?
explanations
Stop
rather than
straw manning.
demonstrations.
Stop straw manning.
Demonstrating,
I'm trying
that's
to, if you would shut up and listen. The horizontal, 90 degrees is a horizontal. Is it not?
I don't care about your explanation.
Is
I
a
want to see it
90
done.
degree a horizontal or a curve?
I don't care about your explanations or any
Ruth,
questions to
stop
me.
being
Draw
dishonest.
your circle
Stop
of equal
being
altitude. Just assume that
Stop
I agree
being-
with everything you're saying,
stop
right?
being
Just
di-
assume it.
Stop
That's
being
fine.
dishonest.
Idiots.
Right?
A 90 degree.
Just
I'm going to mute you,
like,
Ruth.
just
You,
assume that I
you
agree.
want you don't want me to actually demonstrate it, do you? Because I'm trying to get to the point,
I'm waiting
but
for you.
you don't want to understand the foundation of getting to that point. The
Just assume that I agree.
90,
Go and draw it.
90 degrees is a horizontal. Correct, Ruhif.
Just assume that I agree.
90 degrees.
And draw that circle.
It's a simple yes or no. 90 degrees is a
Whatever.
horizontal.
Assume the answer is yes, right? Assume it's yes, and just draw your circle.
90 degrees, Ruhif.
Whatever.
Is-
Yes, just assume.
Okay,
assume yes.
horizontal.
Go.
Great.
Keep going.
So I
Don't ask me
measured.
questions. Just do it.
Can you shut up?
Just do it.
Are you finished? Are you finished?
Yes, do it. Draw a circle.
Congratulations. I measured, sorry, excuse me, over a horizontal plane. Exactly, television, 90 degrees at GP. He's not getting that. That's what I'm trying to get into his head so we can actually demonstrate it to him because he's really not getting it. 90 degrees is a horizontal to the GP of the star. That distance I gave you is done on flat math. It's not done with any curve whatsoever. Heck, Proto literally proved it in his video. 90 degrees is the baseline to get your co-altitude angle, which gives you your distance, your arc length distance, as I showed previously. Okay? So, now when you take a map, it's a coordinate system. We got 50 degrees on a map. You're drawing a 3,000 nautical mile circle around that 50 degrees on a coordinate system. Now, when you get to
Right,
your
do
next
that.
fix, you do the same thing until you get your fix. Simple as that. There's your demonstration.
Okay, do it. Draw a 3,000 nautical mile circle on a map. Do it.
Okay. Don't know why you have to do that, but simple.
Because you want to find where you are, flat soil.
Okay,
The
would you-
whole purpose
would you
is
please
to
give
find
me-
out where you are.
Would you please give me a map I can draw it on? Doesn't matter which map it is.
I will give you the globe, right?
No,
And
a
you'll draw
map.
on a
I want a
globe, and I'll say go over to the
two-dimensional
globe.
map. I want a two-dimensional map, please, not a globe.
Then whatever map you think works on flat Earth, I don't care what it is. Whatever
Any-
map you think works,
any one
draw
of
a
them.
circle on that map.
Any one of them works.
Okay.
Any map.
Mercator, fine. AE. You do AE. That's fine.
Okay, let's do AE then.
Want to get an example?
Hang on, Bacon. Hang on. We're going to get into draw a circle.
I first have to look for a high definition. Identity, I'm talking to Ruhaf that doesn't
Okay,
understand
yeah.
that a 90-degree angle means flat. I'm just going to save it. Hopefully it's going to be able to give it.
The fact that you're searching for a map means that you have never done this, correct?
Not on this computer, correct?
Okay.
Yeah.
Okay, sure. So you're saying you have drawn circles of equal altitude before?
Yes, because circles are two-dimensional shapes on a two-dimensional thing. Okay. It's a bit difficult now because it's not high resolution. So how am I going to draw 3,000 nautical miles to scale?
Find the GP, wherever it is. Go back to the
I
shader.
can't see anything. It's not high resolution.
Yeah.
That's why I'm asking. Do you have anything I can do it?
Probably got a high resolution AE map, probably.
You know what? I got a plan. Roof, have you got a map by you? Can you share your screen?
Yeah.
Can you share your screen for me?
Yeah, 1 second. I'll find this map first.
Cool. And if you can take a Gleason's map and draw on the coordinate system a 3000 and whatever.
I'm not
circle
drawing your
markers.
circle.
No.
Sorry.
No, you can do it.
I will give you the map.
I'm literally going to talk you through it on what to do. How's that?
Okay.
Right,
Alright.
when you stick
So I've got
the
3 meg
Discord
for
link
you,
in, please,
Sorry?
in chat.
Sorry?
Stick the Discord link in. Can you stick the Discord link in chat?
Okay, invite server.
Hang on
I
a
think,
second.
who's it who's asking? Has he seen that who asked me?
There we go.
Oh yeah, Simon, he says, I think some,
Okay.
bull,
There we go. The link is in. But have you guys noticed how Ruef has literally tried to pass the fact that the distance was shown based on a 90 degree, which is horizontal. Which makes
don't need
the whole-
migraine, Fatsoid.
You
don't
do need.
migraine.
How do you have a 90 without have an elevation angle without a 90?
Yeah, I'm just trying to get you to draw a circle, Fatsoid. We can talk about angles all you like, but at the end of the day, you will not show it
Okay,
working on a
great.
photo.
Go to 50 degrees, please.
Hang on, take a look. Am I sharing PowerPoint? Is that right?
I can see
Can you see what PowerPoint's
it looks
doing?
like a AE
Hang on,
projection.
it's the wrong window. 1 sec.
Okay.
Wrong window. Share the PowerPoint. Would I have to share screen? Does that work?
Yeah, I can see you. I can see your
Okay.
screen.
Sometimes when I share PowerPoint, it doesn't work.
Okay.
All right. So where am I going? What's the GP?
Go to 50. What does
50
it?
latitude.
Yeah, 50 degrees and 27.4 minutes. So the ground position is
50
50.
degrees.
No, the ground position is 56. That is,
What's the GP? Where am I starting my circle?
It's 56 degrees.
56 degrees north.
Yeah, and let's go
Yep.
37 west.
37 west. Are these 10 or what are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're 10 degrees east, 10 degrees each. So you're 37 west, 1, 2, 3 there, and 56 north.
What did we say? 37 west and 56 north.
Alright, so GP is like there-ish, if you can see my cursor.
Sort of, yeah. Okay, now draw a circle equal altitude 3027.4 nautical miles.
Okay, that's the question. Alright, how do I know the coordinates of a point from this center point that's 3,000 nautical miles away? Alright, if I have the latitude and longitude of this point, the GP, what are the coordinates of a point to the east?
You literally take the point I just gave you, the coordinate system. That is your point
Yep.
of start. Then you make a
Right.
circle around that point of equal altitude. Do you get it? 3027.
I understand. I have to make a circle, 3,000 nautical miles.
So
right?
click where the GP is, where that
Yep,
pinpoint
I'll make
was,
that.
and then draw a
I'll make that red.
circle of 3027 nautical miles, please.
Right, okay, so that's the question, Flatsoid. This is the problem that you have. Let me just change this to a different, I'll make that red.
How many circles do we have?
So far we're on the
We've
first
got one at the moment.
We're on the one.
Let's zoom in on that, actually. All right, so there's, oh shit, let's move it. There we go.
Sorry, how did you get it to that point though?
Isn't that 56 north, 37 west?
I have this automated. If it helps, I can drop the link, and you can place
yeah,
circles of
that'd be
equal
cool.
on the A map.
Yeah, if you can do that for whoever.
Like actual circles. Yeah, Bacon can do this. He's got better skills, but you know where I'm going, Bacon, right?
Don't worry, Taylor. Yeah, I got a problem.
But I want to, like, you, Flatsoid, right? If I draw a circle here, let's draw a circle. Oh, shit.
You can stream the link I sent you. You're gonna do it much faster there, I think.
Where'd you send it?
On live stream comment,
Flatsoid,
I tagged you.
Sorry. Yeah. All right. Boom. Now, and they're actual circles. Oh, very cool. All right. Let's share that window then. Change windows to that one. All right. So you can see that now.
Ah, that's better.
Very cool.
Bacon, that's
All
awesome.
right. So, what's the GP again? Let me know the GP.
The first one, I think it was, Shredder was 56 degrees, 39.7 north.
7 north. Yep.
And then 7 seconds. Then it was, 7 degrees.
Oh, okay. Yeah.
North 7 degrees, 37.5 west.
37.5 degrees west.
No, 7 degrees, 37.5 west.
7 degrees.
Yeah.
0.5 west, is that right?
37,
and what was the angle?
37.5. The angle is 50 degrees and 27
Yep.
minutes, 0.4 seconds, yeah.
What do
It's the zenith or the...
Yeah, it's
You need to
cosine.
separate them with a comma. Like
Yeah.
you need to
So
put a
that comes
comma.
after N.
Yes.
And times W. Yep.
9.7.
Yeah. That 50 is the zenith or is it the altitude?
It's 50.27. So let's just say it's 50.27.
Yeah,
Don't
there's
have to
the
worry about
co-altitude or
Co-altitude.
the elevation angle.
co-altitude.
Co-altitude.
50
So
degrees.
What do I put in? Bacon?
That's it. Yeah, it's
Yeah.
expecting the radius. Yeah, so it's the co-altitude.
Okay, cool.
That's right.
50, 27.4.
Okay.
All right, there we go.
Now we.
So there's one circle.
Yeah. Okay. The next one is 16 degrees.
This is the GP for the next star.
Yeah. 16.22. 1622.8. 16 degrees, 22.8 south.
22.8 south.
Yeah.
55, 53.5
West. Co-altitude is 65.
57.6
Yeah.
minutes.
And the distance
All
is
right.
3,957 nautical miles.
Yeah, cool. On 3.
Okay. Next one.
I'll wait until it comes up on the screen.
I'm looking for it.
In YouTube.
Alto, there we go. 8 degrees. 8 degrees, 55.8 north.
Yep. 80, 27.9 west.
Yep.
34, 29.3. Boom.
2069.
All right, how do we zoom in, Bacon?
I can't get my mouse to work
You
now.
don't, but you have the coordinates right there in the other box.
Oh, okay. All right. So where is that? And is that like the center of the intersection? You draw a circle in the middle? Yeah, okay.
I don't remember. I think so.
Okay.
I think it minimizes the square of the differences between the radiuses.
Did you create this program, Bacon?
Yep.
That's quite cool.
Thank you. If you want one works, there's a globe one too.
Oh, so we're in the middle of Lake Erie, apparently. But where did he take it from? He took it from Lake Michigan, Milwaukee, somewhere. So Flaxoid, let's just measure a distance, shall we?
Let's go to where he pinpointed his position.
That's
We can check.
Toon's challenge.
There we go. 42. He ended up at 42 degrees 30 north and 87.30 west.
There you go.
He ended up at 42 degrees,
Yeah.
30 north and 87 degrees 30 west.
Which is Wisconsin, right? Kenosha, Wisconsin or somewhere.
No idea. I think it's next to
Oh,
Lake
man, what were
Wisconsin
the-
about.
what were the
Look on the
coordinates again?
screen quickly. 42 degrees,
Yep.
30
Yep.
north, 87 degrees,
Yep.
30 west.
What was the west? 87 something? 30. All right.
87.30, yeah.
All right.
Is it the $100 challenge?
No, this was Proto that did
Yeah.
it himself, this measurement.
Yeah.
Oh, right.
Yeah, he was actually at either Kenosha or what's the fucking city called? Milwaukee. Sorry, Milwaukee. He was either Milwaukee or Kenosha. So Flatsoid, doing
Yeah.
it on an AE map,
Yeah.
right? The circles don't intersect.
Where don't they
Right?
intersect?
They don't intersect at a single point.
Okay, go show us.
It's showing it on screen now.
No.
The distance from
I'm
the
showing.
fix,
We.
your fix, to the actual fix is 544 kilometers away.
Wow, and that how makes it that you're wrong?
If your fix is 544 kilometers away, do you think that's a good fix?
Not bad.
Bad, right?
No. Remember, you're using an AE map, which has
Right.
distortions on it, and we both agree it has distortions.
Yes. Yes, it has distortions.
Great.
Because it comes from a globe without distortions. As soon as you transform something spherical into something flat, it will distort.
Can you try do this
And
now?
there's distortions.
Can you try do this now
Right.
on a Mercator map as well?
Bacon, do you have a Mercator on this?
I don't.
Oh, okay.
If
No.
you give me
All right,
half an
okay,
hour,
okay.
am I?
This is pretty cool though. I like it.
But
If
do you
you
get
could zoom
but
into
you
that fix,
but
that'd be
you
cool as
get
well.
you get what you just did though.
What?
But you get what you just did though.
What did I just do?
He measured angles, correct?
Right.
From
Right.
a flat horizontal baseline, and
No,
then
we disagree.
wait,
the
listen.
horizontal baseline is an imaginary line, but continue.
And then he did math from a 90 degrees minus the angle measured, which gave a co-altitude angle, times
That's
the
the definition
60
of co-altitude, yes.
times the 60 to give your distance, which gives you your
Right, which doesn't make
circumference for
sense
the
on a flat
circle.
Earth. That's a globe.
It did, and then you drew it out based on a coordinate system, correct?
Right, yes, and we were wrong by 544 kilometers.
You just did celestial navigation on a flat Earth that you said was impossible to do. You do get that, right?
Are you okay with 544 kilometers?
Yeah, because I don't ascribe to that map. So yes, I'm more than
What
happy
map
about
do
that.
you ascribe to?
You don't understand. The math used was flat, correct? The measurement was taken flat, and you got a fix.
We were
Correct.
544 kilometers away from where he
No,
was.
what is the
He called it
globe?
a
What
fix.
is the globe argument? It is impossible to do it on a flat Earth. You just did
my
it.
God.
You just listen.
Oh, it's
You
impossible
just
to get the right
listen.
result.
Listen. You just
Yeah.
did it flat. Do you understand that? Now, again, you used a map that has distortion, which I do not ascribe to at
Right.
the beginning.
Okay,
So,
then give us the map
that-
that you draw your circles on
I
to
don't.
do this. What map do you draw your circles on?
I don't need to draw on a map because I don't need to do celestial navigation.
We're asking you to, though.
Do it on the Mercator
Because
map if you want to.
you're portraying yourself as an expert here, right? You've never done it.
You
Never done
don't.
it,
You don't
ever.
get the argument here. It's not about the fix. It's about you literally just done celestial navigation from flat. Do you understand that?
500 k's off. 500 kilometers
I don't
away.
care if it's a million k's off. You did something that you said was impossible flat.
Jesus.
The angle measurement, elevation angle, horizontal flat. The co-altitude angle, which comes from a 90-degree flat. The distance you worked out came from what? A flat math equation, you can say. And then you drew a circle of equal altitude flat. Do you not get your issue here, Ruhif?
This will go down in history, Flatsoid, as you proclaiming that 500 k's off is working on a flat Earth. This is
Will you
hilarious.
okay? Will you get a different fix on a different map?
You'll get a correct fix on a globe.
Will you get a
Flatsoid. That's the
different
point.
fix? Will you get a different fix on a different map?
Any other
Yes.
map besides the globe,
Great,
you'll
great.
get a fix,
Bacon,
and
bacon
it'll be
is at
wrong.
least honest. Bacon is
It
honest.
will be wrong.
Bacon, so it gives you a different fix on a different map, correct?
Yep.
A wrong fix.
Great, okay, but we used exactly the same math and method to get that fix, correct, Bacon?
No.
No. Otherwise, we would get the same result. We don't.
Okay, let's test it out. Quickly bring up the Mercator map and do exactly the same we just did on the
Yeah.
Mercator and see if
He
you're going to
hasn't
get
got
the
one.
same result. No, come on, you made a
You're not
claim.
at a difference.
You made a claim. I'm holding you toes to the fire.
No, you made a claim that this would work on a flat map.
It just did. You
draw
just
it.
did it.
I'm asking you to draw it flatsoid.
Why? You got
If
the
you want me to
program.
draw it, I will do it on a globe.
You got the program in front of you. So use a Mercator map if you want to. Or which other maps do you have, Bacon, on your program?
That one is only for the email.
Do you have another one that's another map?
We could probably do a equirectangular for the next stream. I reckon that would be pretty simple.
Yeah, that's.
But it's up to you, flatsoid. Like I said before, if I have a point that's in the center of this circle, how will you tell me what the points, the coordinates of the points that make up that circle?
You still haven't.
How will you tell me if I'm at point A, the GP of the star? Give me the coordinates of the point that is, say, at an azimuth of 45 degrees, 1,000 nautical miles. That's your challenge. That's what you need to draw a circle on a map.
Again, we literally went through it together now. You drew a circle of equal altitude on a map based on a 90-degree angle. Are you not seeing your issue here? Do you know what 90 degrees means, Ruhaf?
I do know what 90 degrees means. Do you not see that we're 544 kilometers off?
That is based on the map you used, Ruhaf. I don't
Right,
care.
so use the correct map.
I said you can use a Mercator map if you want to. It would give a
Okay,
different result.
Then do it on Mercator.
Would it give a different result, Ruhaf?
Yeah, probably.
With the
yes.
same information, Ruhaf?
Yeah, it will not give you the correct answer of where you are.
So navigators don't use Mercator maps. Is that what you're telling me?
Not for drawing circles like this, no.
Ooh, Arctic reflections. Ruhaf says you don't use Mercator maps for doing circles of equal
No,
altitude.
not for drawing these circles.
Yes, they do.
You draw a circle on a Mercator. Ask Arctic Reflections if he draws an actual circle on a Mercator, will it be distorted relative to reality? And he will say yes.
So the
We can
navigation.
bet on this if you like.
All the navigators in the Navy don't use Mercator maps now. Is that what you're claiming?
I'm not saying they don't use Mercator. I'm saying drawing a circle on a Mercator will be distorted in reality.
Yeah, do
If
you know...
ask Arctic Reflections that, he will agree. Would you like to bet on that?
What's a globe map, Jim? So which maps do navigators use, Ruhaf? To draw a
Well,
circle
they
of
use
equal
things
altitude?
based on the globe.
Which maps do the navigators use, Ruhaf, to draw
Yeah, any
circles
map
of equal
that's
altitude?
based on a globe.
The Mercator's
Like
based on a
James
globe.
Smith just said in the chat, the globe is the only correct map because any flat map representation will have distortion.
So Mercator map is a globe representative map, correct?
It's a distorted two-dimensional representation of a globe.
And
It has massive
navigators
distortions.
and
You should know it has
navigators
distortions.
and navigators use Mercator maps to navigate, correct?
As long as they understand the distortions, fine.
Great. So they use Mercator maps, which is based on your globe, and it
Right.
gives
Distorted.
that. So it gives a different fix.
If you try and draw an actual circle on a Mercator map, that circle will be distorted in reality.
Okay. Would you please
If you
show me
ask
a?
Arctic
Would you
Reflections
please
that,
show
he
me
will
a?
agree.
Would you please show me a globe map?
Google Earth.
No, that's not a map.
Yes, it is.
That's a 3D representation of a coordinate
Who
system.
says maps have to be 2D?
Maps are
Why
two-dimensional.
can't I have
Yes,
a 3D map?
it's a.
Who says it needs to be two-dimensional?
Your Cartesian system is two-dimensional. Do navigators
Okay,
actually
flat line.
use globes when they navigate, or do they use
No.
maps? I mean, let's take even Wolfie, for instance. Does he fly around with a globe in his airplane, or does he have maps?
Yes. Sorry, does he have maps or math?
Maps or a globe in his cockpit when he flies?
He has maps, right?
Great.
Again, they are globe
Okay,
maps.
so when he navigates, he uses two-dimensional maps.
He has a two-dimensional flat iPad screen. Is that what you're talking about?
All the maps used for navigation, you cannot deny this, is two-dimensional. All maps.
When you're showing it on the screen, of course it's two-dimensional.
Sorry, all maps are two-dimensional when navigating.
No.
Show
No.
me a three-dimensional navigation map, please.
Sure. What's the one you use? Bacon. Do you remember what he uses? It's the flight planner.
Based on the Mercator map. Congratulations.
No, it's literally a globe. It literally shows
The drawing of the globe is the data based on the Mercator map.
It's not based on the Mercator map. Mercator is a distorted projection. You should know this by the size of Greenland, Flatside. You know it's distorted.
Distortions of lands is on every single map. They
Except
still
the
use
globe.
Mercator maps. You just said 5 minutes ago they use the Mercator map. Now you are
Right? As
saying
long as
they
they
don't.
understand the distortions, that's fine. Right? But if you're trying to draw a circle on a Mercator, it will be distorted in reality. This is
Every
such
map
basic
has
stuff.
distortions. You agreeing with me?
Not a
Every
globe.
map has
No,
distortions.
the globe does not have distortions. I'm disagreeing with you. The globe does not have distortions.
And yet navigators don't use globes when navigating.
They use globe maps. Yes, they do.
Globe maps. So two-dimensional
Yes, they do.
maps.
Oh, if you're looking
Show
at
me-
anything
show
on
me-
a piece of paper or a screen, it's two-dimensional.
Show me
Right? It doesn't.
show me a globe in a cockpit of an airplane, or show me a globe
Sure. Look,
in,
if I can
on a
remember the
cockpit of
name
a
the
plane.
flight-
Show me where they're
flight
drawing
mapping.
circles on a globe, please, while they're navigating.
Flight mapping.
Maybe you should ask Wolfie to show you all his logbooks and show you the maps inside there.
I'm trying to remember the name of the one he uses, and it is a globe. Like it literally shows you a globe.
Again, having a depiction of a three-dimensional globe on 3D software does not make the navigation based on that drawing of a globe. They do it
Yes, it
over a
does.
two-dimensional map, which is
No, they
90%
don't.
Mercator based.
Here's one. Let me can I post this in the chat somewhere? Let's chuck it
So
over
we're going to
there.
end your screen then.
Oops. Hang on, put on the screen. Oops. Alright, that's not actually the one he uses. by the way.
What's the data used for that so-called globe
Hang on,
recording there?
is that coming up on the screen now?
Yeah, I can see it.
Yeah, okay. So what does that look like?
Again, you're not
Is it a
understanding.
globe?
It's a
Is it a globe?
drawing of a globe based on the Mercator data.
It's not based on Mercator Flatsoid. It's based on a globe. The underlying mathematics from point to point is Haversine. That's a globe.
After what
you asked for a
distances?
picture
So can
of
I
a
get...
pilot
Okay,
in a
this is what I'm
cockpit
going to ask you
using a
now.
globe to navigate.
So I'm going to ask you now. So the math I've just shown you... so the math I've shown you here... Where is it now?
No,
This-
Spud, I'm
this-
not asleep. I'm still here. I'm still
Okay,
here.
shot PJ. It's very simple, Ruaf. So the math I showed you here, does it give you the correct distances?
You have no basis for doing 60
Do
north
they
and north
give
degree.
you... Yes, I do.
No, you don't. You got busted on that the other day by
What's
Petey.
a- what-
Petey's in the chat.
what's
How
a
good
s-
is Petey
what-
with
what's a circle?
GeoGebra?
What's a circle?
Oh, fuck, wait,
Is
I
there
think we're done,
360
right? I asked you
degrees?
to draw a circle
Is there
on a map.
360 degrees in a circle, Ruaf?
I asked you to draw a circle on a
Is
map.
there
We did that on
300?
the A
Is
map,
there
and you're
360
off
degrees?
by
Why are you
544
over
kilometers.
talking me? Is there 360 degrees in a circle, Ruaf?
Don't ask me stupid questions, Flatsoid.
Yes or no?
Don't ask me stupid questions.
You know, because if you're going to answer me, you're going to validate it. Is there 360 degrees in a circle?
Don't ask me stupid questions, Flatsoid.
Guys, this is why
Continue.
Ruaf, this is why everyone calls Ruaf dishonest and disingenuous. Because
Get
every
fucked,
time you
Flatsoid.
ask him a
11
question,
frames,
he,
Flatsoid, get fucked.
ooh,
The most dishonest
triggered,
prick on the face of
triggered,
this fucking planet.
triggered,
Oh, triggered. Well, triggered.
triggered. Ouch. So guys, and he is still, yeah, Ruaf. So again, how much degrees are there in a circle?
I'm not answering rhetorical questions, Flatsoid. You know the answer. I know the answer. Just continue.
So you would agree, 360 degrees in a circle.
Well done.
Great.
Well done.
So let's look. When you're looking at a celestial sphere, correct? Is there 360 degrees in a celestial sphere?
Both above and below you, yes. The celestial sphere has stars in every direction.
You know how quadrants work, correct? Like a clock face,
yes,
quadrants.
90 degrees.
Okay, so when you're standing and looking 90 degrees at something, you would agree you don't have eyes in your back.
Spud says, ask him the definition of an angle. He seems to have skipped over that.
No, we'll still get there. We're still working on 60 nautical miles based on angles.
Got ya.
So, we work in quadrants. We don't have eyes in the back of our head. So if we sit and we measure an angle, an angle is based on an arc, correct?
No, it doesn't have to be an arc. It's just two
yes.
directions.
What's a 30-degree angle? Is it
It's
a
the
radius?
difference between two directions.
Is it a radius to
Separation
circumference?
between two directions.
Is there a radius to circumference when you're measuring an angle?
No, don't have to be.
Really? So there's no radius to a circumference when you measure an angle?
The angle is just the separation between two directions.
Which gives... Let's say I've measured 30 degrees in the sky, correct?
Okay, right?
What is...
You've measured the separation between two
What
points.
is a degree?
Right.
What is a degree?
We're just talking about the separation between two points.
What is a degree?
It's an angular measurement.
Great. So 30 degrees means it's 30 degrees of angular measurement
Right.
of a 360 degree circle.
Can you see what's on my screen? Is that an arc? Is that an arc on the opposite side?
The arc is based on the hypotenuse.
I'm some distance away from the tree horizontally and some distance away from it on the hypotenuse. They're not the same distance.
Does the hypotenuse distance change based on the angle you're measuring?
Sure.
So it creates a arc relationship between the hypotenuse and the horizontal.
You can create one, sure.
So let's go.
An angle is just the separation
So
between
go to
two
my
directions.
screen.
That's all it is.
So go to my screen quickly. You can see my screen. I've got it on now.
You're not sharing
It's
on your live stream or
On my
are you
live stream.
sharing?
On my live stream. Would
On
you
YouTube?
on YouTube? Would you be able to go there quickly?
I'm there, but it's showing me because it's delayed. There we go. Fine.
Okay. You see those lines at the bottom?
Yes.
Those
They're
are
equally spaced. Well done.
those are the hypotenuse lines, just made horizontal now. Can you see they all have a different hypotenuse distance?
Yeah, they're all pointing to different stars.
And every single one of them have an angular measurement.
Right, pointing to
So-
a different place.
great.
Yeah.
So
they're
if-
not pointing to a single star.
So if you change an angle measurement, the hypotenuse distance changes.
Sure. Well
So
done.
you would agree the hypotenuse distance has a relationship to the horizontal distance.
Right, welcome to trigonometry.
Great. So an angle is depicting an arc of a circumference.
If you wanted to.
Not if you
Sure.
wanted to, that's how an angle works.
Well, then go back to my screen. Is that a circle? I can make a circle.
I just
with the
explained to you
with the hypotenuse.
why. Yes, you can make a circle from it, correct? Because why? The
Right.
hypotenuse's relationship to the horizontal is the reason you have an angle measurement, a degree. And we have
You don't have to talk slowly,
360.
Fatsoy.
Well, I have to because it's like talking to a 2-year-old. Never mind a 5-year-old. I'm serious, dude.
Okay.
This is how stupid it is that I have to explain things like this to you that does literally understand geometry and math. That you're trying to obfuscate from the fact that a degree angle measurement is based on a 360 degree circumference. It's like a clock face.
Is my screen? Like, where's the circle in my screen? You know, I'm measuring angle, sure.
Where's the circle? That X.
Yeah, I don't
That
have
x,
one, right?
that
I don't have
x,
a circle.
that x, is there an arc
I
in
can
the
make one.
the x degree? Is there an arc there?
I can make one.
Is
I
there
haven't
an
made
arc?
one. I
Is
can make
there
one.
is there an arc in the x degree?
No, it's a flat. My
No arc.
opposite side's a straight line. I don't need a circle here. I
I'm
can
sorry,
make one. Fine.
sorry. So a degree measurement is not an arc now. Is that what you're telling me?
It doesn't have to be. It's just a measurement of separation
Guys,
between
this
two
is Ruaf being
directions.
totally disingenuous.
Oh, don't Flatzoid.
An arc measurement. An angle is an arc measurement.
This thing
Prove
I'm showing
me
on
wrong.
screen is not a sector of a
Prove
circle.
me wrong that
I
an
can make
angle
it a
is not
sector
an
of a
arc.
circle
Prove me.
and agree with you, but then what? This is such a pointless conversation.
Yeah, it is a pointless conversation because you're literally being dishonest and throwing away what an angle
Fuck
is.
off, Flatzoid. Don't be a fuckwit.
Triggered again.
Don't call me a liar. 'Cause
I'm
you're
calling you a
fuckwit,
liar
right? Don't
live
do
in
it.
front of everybody here because you're literally showing an
Don't.
elevation
Don't.
angle that and denying that an angle
Do you want
is
to
based
talk
on
about
an arc.
liars? Claiming that celestial navigation works on a flat Earth when
just
your
did it.
fix was 540 kilometers away. You said that works. That is just fucking so dishonest.
You did it on a distorted map.
Right, get your
but the
map
point
then.
is-
Use a map that is not distorted. That should be easy on a flat Earth.
No
Get
maps.
an undistorted map.
There's no map that's not distorted, and you literally
Except
conceded
the globe.
that you conceded.
Except the globe.
You literally conceded no matter which map you use, you're going to get a different fix with the same
No, you'll get a
data.
correct fix on the globe. Every flat map will have a distortion. and therefore an
Sorry,
incorrect fix.
you know Proto Thad had his out as well when he did McToon's challenge. And he did it
And he's
on
got
a
out.
globe, exactly on a globe. And he had it out. Did he not?
By how much? By how much?
It doesn't matter. He had it out.
Yes, it
You
does.
said it would be perfect.
No, it's never perfect.
Oh, great. So even a globe
It's
is
not
not
perfect.
correct. Congratulations. So even a globe is not correct. And again, a globe is not a
By how
map.
much?
The globe and
A
oh,
globe
that
is not a
challenge
map.
is is that a $100 challenge he's talking about?
Yeah, Bacon
was
won the
our-
$100 challenge. Tell Flatzoid
Yeah,
about the
I-
$100 challenge, Bacon.
Yeah, use the globe for that one.
Great. And
And
how far off were you?
how far off were you from the exact fix?
5 miles, I think.
And you used
5 or 6
you
miles.
used a globe.
Yes,
And the globe is supposed to be perfect, correct?
that was a perfect sphere used here.
Congratulations. So the globe is not perfect as Ruaf is it just literally said 2 seconds ago.
What do you mean?
In other words,
No one said they were
it's
perfect except
in other
you,
words, it's a
Flatzoid.
straw man to say all maps are distorted and the globe therefore is correct when the globe also has fake distortions. Congratulations. So globe is also
It's
then
not
fake.
distorted, Flatzoid. It's not distorted.
If it's not yeah, Lotion, go ahead because I'm trying to explain to them that a globe, if it doesn't give the same fix all the time, is just the same as using a map that has distortions that also doesn't give
No.
because you don't understand.
You were
No,
500,
you literally-
544
I
kilometers off.
don't care, even if it's 1,000
That is
kilometers.
100 miles.
The point is, you literally did something you said was impossible. Do you get your issue?
If you think being 540 kilometers off is working on a flat Earth, like I don't know what to tell
And
you.
I would have a different result on a different map, based with the exact
Yeah, a
same
wrong result.
data. No, you would have a different
Yes.
result. So the map is the resultant of the fix, not the data. Correct?
Whatever map you use that's not the globe, you'll get the wrong fix.
Can the data I
Use the
gave
globe, you
you,
get an accurate fix.
can the data I gave you, which was based on flat, work if you
No.
did it on a globe, as you say?
Yeah, you'll get within a few miles on the globe.
So the
yes, if you
data's
use that,
correct. So the data's correct. And I gave you the data based on flat, correct?
No.
Oh, really? Tell me again how 90 degrees is not flat.
90 degrees, right? You've got vertical, right? And horizontal is simply 90 degrees to that. It's an imaginary line. It has no correspondence to the shape of the Earth.
What's a co-altitude angle?
90 minus the elevation angle.
Congratulations. So if you don't have a 90, you cannot get a co-altitude angle, correct?
Right? But again, horizontal is not
okay.
a reference to the surface of the Earth. It is just an imaginary line that is by definition perpendicular to down.
And now let's put it this way. Is the GP on a circle of equal altitude the same equatorial plane as the observers?
It's not on the same plane, no.
A circle of equal altitude is not on the same plane as the observer?
The circle of equal altitude is like the cap of a sphere if you were to slice off a cap of a sphere.
Are you saying the GP of the stars is not the same equatorial plane as the observer's GP?
You're using the word equatorial plane incorrectly. It's not on the same Euclidean plane.
Is it not on the same equatorial plane?
You keep using that word equatorial plane incorrectly.
What does equatorial plane mean?
It's the plane that's basically at the equator. So the equatorial plane of the celestial
It's the plane
sphere
that's
is
cut
the
through
equator,
your,
basically.
so it's the plane that's cut through your sphere to have the same horizontal plane. It creates
what you're trying to say-
wait, it's the
what you're-
base. It's the base of your triangle, correct?
Right. What you're saying is that it isn't. You're saying that it's a triangle, a 90-degree triangle between the observer, the GP, and the star. That is incorrect.
Literally, celestial navigation is based on the GP of the star having the same equatorial plane as the GP of the observer. In other words, you are correct. You are literally going and triangulating with a triangle.
It's not a triangle, Flatzoid. Not a triangle.
You've got a triangle on
this map,
screen
this
right
map
now.
I've got on screen, right?
Yeah.
Right. This is trig, right? This could equally apply to the star, right? If the star was up here,
Yeah.
and this was the GP down here, and here's your observer,
Yeah.
right? This is a trigonometric relationship, not a 60 nautical miles per degree relationship.
Sorry, what's a degree measurement again?
Flatzoid. Well, I've said it 5 times. It's the separation between two directions.
If I have 1 degree angle measurement and I measure then a 3 degree angle measurement, is there a arc relationship?
You can make one, sure.
You can make one. You have to make it up. It's not.
But
Look,
on
this is my
screen,
question.
it's a
This is my
triangle.
question. I have to
not-
question. No, I'm questioning this now. Why does everybody have to go on 360 degrees for a circle? If you split, they say a degree is 69 miles. Well, what if I chose to make a degree, I don't know, 23 miles? How many degrees in the circle then?
Still 360. Always 360 degrees in a circle.
No. Because if I make a degree only 23 miles, that means there's going to be more than 360. 360 was a number that was given to make up math so that you stuck with it, so you didn't ask any more questions.
Based on
So
the
you
circumference.
just kept in your little confinements.
It's based on the
A
circumference.
degree was made up. A mile was made up. All of that shit was made up. If I cut a fucking pizza into 8 slices and give each one of those slices, the median or slice, okay, I'll call each one of a degree. I can slice that pizza as many times as I want, and each one can represent a degree. I can make as many as I choose. What do you do with 360? Of course, it's going to be distorted. Of course, it's going to be distorted on anything you put it on because of the number that you were given.
You just made a relationship between 1 degree and 23 miles.
You are
Okay,
stuck.
guys.
You are stuck.
I
at
just-
a
You're
degree
right.
is
I just-
69 miles.
I just gotta say, I got a super chat.
You can slice the map up as many times as you want. And you can give it as many degrees as you
Lotion,
want.
lotion.
But why
You
why
made
is
it.
everybody stuck on 360?
Sorry, Lotion. I got a super chat. Sorry, better than gold. Thank you for your $5 super chat. Really appreciate it. He says, Earth is proven flat, demonstrably and biblically, if I appreciate the sword. Yes, mate, for sure. It's definitely been proven. Even Ruev proved it tonight. You can do celestial navigation based on flat Earth.
500 Ks, 540 Ks.
Again, you would get a
Good luck to
different, you would get a different measurement on a different map, Ruev. You literally just did celestial navigation from flat measurement. Now you are running away from what an angle is. Congratulations on being dishonest.
Oh, wow. Okay.
Yeah,
Yeah,
it's
if you think 500 kilometers is good enough.
This is,
that's
guys,
fantastic.
guys, look at
That's
this.
clippable.
Guys, look at this day. This is the day that Ruev did flat Earth navigation and complained and says it's not flat Earth.
You're very wrong.
Oh, wow.
Lotion, you did see the same thing I saw where he did flat Earth navigation, correct?
I saw all that, but
Yeah.
everybody is stuck on this 360 degrees. 360 degrees was made because, like I said, back in the day, there were smart people and there were dumb people. But they weren't really dumb because they were asking smart questions to the people who thought they knew it all. What they thought the world looked like. What they thought it looked like. So eventually they asked so many questions that the smart person said, look, here's a circle, it's 360 degrees, here's your math, shut the fuck up. Depending on whatever math you choose to use, you can divide that circle into as many sections as you damn well want. And you can make you could make an infinite amount of degrees. If you're saying there's 1 degree, 1.5 degree, 1.0025 degrees, there's an infinite number of degrees, depending on what number you give to that shape. But why is everybody still stuck on 360? It's because it's the math that was given to you, so you just shut the fuck up and don't ask questions.
It's because of pi, Lotion.
People don't get
360. I don't think you understand. 360 degrees is a completely arbitrary division, right? The relationship of 1 degree, whatever a degree is, to 60 nautical miles is a relationship between the circumference of the Earth.
How many times they sliced it up?
Yeah, but whatever a degree is, let's
How
say
many
it's
times they
360.
sliced up the map? They gave a distance. You can slice it up however many times you want. You can
Right, but
slice
let's
it up
say
a
there are-
million times in a circle, and it can have 1,000,000 degrees.
Right, but let's say we have
You understand that?
3,600. Yes, let's say we have 3,600 degrees in a circle, and I said
Why
1
are you
degree
going
equals 6
360?
point. I'm
Say,
finished.
why don't you say like
I said-
7,242?
I'm just
7,242,647 degrees.
Just making
Now
it
do the math
3,600. I'm
It's gonna
just
be
making it
distorted, no matter what you do.
I'm just making it 3,600 because it's just a multiple of 10, right? So let's say that now there are 3,600 degrees in a circle, and I said 1 degree is 6.9 miles. That still defines a sphere the same size as our Earth.
So again,
So then then make it. Then make it 7,242,597 degrees, and then do your math
1 degree equals fucking 50 feet or whatever then. Whatever number that I come up with will still define the shape and size of this planet.
Ruev, you would agree
But
pi.
your
pi
math I won't work anymore.
Ruev, you agree that pi exists, correct?
All that shit won't work anymore.
Yes, it will.
You're using math that was given to you, so you just stopped asking questions. You're not
No,
looking
incorrect.
outside of math. You're not looking
Incorrect.
at observations. You're not looking at reality. You're looking at fact. You're looking at a number that somebody gave you, so that you could play with the globe.
Okay, yeah, I get
Do
what
you
you're saying.
understand that
Lotion?
relationship, that linear
Guys?
relationship of an angle to a distance defines the size of that circle or the sphere?
Okay, guys, I get what you're saying, Lotion, but it's literally going off of topic what we're trying to get to the point here. Ruev, you would agree that there's pi. You understand what DMS is?
DMS.
Yes, decimal.
DMS is degrees, minutes, seconds. What's that got to do with pi?
Great. So, you can understand you can actually interchange, so you can get your degrees in 360 seconds, minutes, and whatever. That's why
Okay,
coordinate
what does that
systems are
look like?
based on DMS, correct?
Say that again.
Coordinate systems based on DMS.
But they don't have to be.
But they can
It could be
be.
decimal degrees. Yeah, it
Yeah,
could be decimal
so-
degrees. Could be radians for all I care.
And what are degrees again?
Separation between two directions.
Based to a circumference, correct?
It doesn't have to be, but
Can
sure.
you go
Okay.
more than 360 degrees?
No, there are 360 degrees in one rotation.
Great. So when I measure 30 degrees, that means I've measured 30 degrees in a 360 degree circumference, correct?
Sure.
Great. So
Let's keep
when now we're getting somewhere. So how many degrees are there in a circle? 360.
360.
So when we measure a quadrant, which is based on a 90 degree, correct?
Right.
That's a quadrant of a circle.
Yeah, well
That
done.
would, yeah. So the math I provided gives you your relationship to 60 nautical miles. Congratulations, Flat Earth.
No, bring up your maths. Actually, no, do show mine on screen.
Yours is on screen still.
Okay, awesome. Okay. So let's say this x, or in reality, this x will be 20 degrees.
Okay.
Okay. You are claiming that this right-angled triangle works for celestial navigation. So I'm going to ask you, if I move twice as far away, what will that angle be, and how will you determine it?
So you're saying we're measuring at 20 degrees, and if I move twice apart away, what would the angle be measured? So you're saying we measure 20 degrees. Is that what you're saying?
You're roboting bad.
So you're saying we measure 20 degrees. Ruth?
Yeah, you're roboting really bad.
Can you hear me? Hello?
Yeah, but roboting.
Okay, because it
I
sounds...
can hear him fine. It might be your connection. I don't know.
Yeah.
It could be me, actually. Bacon's
Who
roboting
even
as well.
came up with 360 degrees? Who came up with 360 degrees?
360 degrees is arbitrary.
Wasn't it Euclid? The Euclidean?
No, who came up with it though? Because that does matter. Because like I said, if you made, instead of 360, you gave it 720 cuts. Now you have 720 degrees. But who came up with 360 degrees?
They're all.
Everybody search Google.
No, you guys can talk. Go on. I'm just trying to
Nobody.
There we go.
draw it out quickly.
I'm back.
That doesn't change like anything. You can use radians. Your results not going to change by any bit. If you split angles into 1,000 parts instead of 360, and you use that consistently, you're going to get the exact same results, regardless of what you're doing. So I mean, it doesn't matter.
There will be people that will snip out this celestial navigation working on flat Earth with a 540 kilometer.
Yeah, and ignoring that it is giving a you showing that you literally did it based on flat Earth math, which you said was impossible.
If you want to say 540 kilometers is quote unquote working, feel free.
It's impossible to get
You
the
know,
right results.
People back then were off from time to time. They didn't just
Or
get it
you-
right the very first time. They came up with a way to navigate, and then when they got to a place that they knew wasn't right, they're like, "Oh shit, we got to try again." You think everybody was perfect back then? They
There we
weren't,
go. Roof,
obviously.
roof on screen.
And there's room for human air. Obviously, you're human. There's room for air.
Roof on screen.
Okay.
So I got the distance, 4,200 nautical miles. It was based on celestial navigation. Went 2 times the path for 8,400 nautical miles.
Okay, so on my screen, right, if I move twice as far away from that tree, am I going to measure half the angle? Like, what angle will I measure, and how will you work it out?
Okay, I must have drawn it like that then as well. Okay. It will be, because it's x, because the distance, you take the distance. Divided. So I'm looking for my, anyway. 2.
Remember, I'm asking for an angle that we will measure in reality.
Yeah.
So in reality, first of all, I should get you to, do you agree that if this tree is 150 feet tall and I'm 400 feet away, and you know my camera's at 6 feet, you know everything in this diagram, if you agree that this diagram, you know, is correct, will I measure 19.5 degrees in reality? Is that the angle I'm going to get? Measure.
Yeah, you can measure it. Why not?
Yes. Okay. But no, is my calculation prediction? Is that the correct prediction?
So 150 feet. Is that actual 150 feet or just optically 150 feet? Well, you work it, Secretary, 400. So yeah, you say 19.5, which gives 400 feet. So yeah, it will be right because I measured.
Okay.
Yeah.
Okay, if I move twice as far, or if I move half as close or whatever, if let's say I'm 200 feet away.
No, instead of 400 feet.
Yeah, but well, okay, let's move 800 feet away then.
Okay,
Either
so you 400 feet now measuring at 19.5 degrees. Now you're saying if you go 800 feet, you would get the same result. No, you won't. Because
what angle will I measure?
19.5 divided by 2.
Oh, okay. You reckon I get 19.5 divided by 2? How about if I told you that we will measure 10.2?
So it's
I
just
measure
under.
10.2.
So
this is why I wanted to go closer.
So it's just
rather than
under.
further away.
So it's just under.
Hey?
So it's just under exactly.
Right, but let's go closer by 200 feet because that'll be a bigger difference. So if I go closer by 200 feet, what angle will I measure?
You see, this is where it gets a bit trickier because it's got to do with the angle, what you're measuring. But yeah, if you get further away, you've already got your distance. Let me try to work it out quickly. You guys can talk on while you're going. I'm just trying to work it out. But you do get what the issue is.
The truth will, like I just said, the truth will never be found using the numbers you've been given.
If I go and measure an angle, right, and it matches my prediction, does that validate the mathematics?
Yeah, your empirical system, your measurement system is based on the needing of the angles to a 360 degrees, so it will always work.
I'm just asking whether tree works.
It will always work.
Mathematical construct.
It's interesting. It's interesting, Flatso, that when I said move away 400 feet, right? You said
but remember we're working. Yeah, I said, and it came out just about half. But remember, when you're going closer, because it's based on optical measurements, it's apparent. It's not really 100% linear because of perspective.
I'm going to measure an angle, regardless of my theodolite's going to read off a number, right?
Okay. I'll try and work it out.
Oh, Gleam's got some numbers in the chat. You're 40. Please, Gleam, how did you get 42 degrees for 200 feet away?
I was thinking more along about 38.
39?
Because I was more on the line about 38 maybe. Let's see, we got 19.5 degrees. You can carry on. See, the thing is, what's confusing me because it's in feet. I don't work in feet.
It doesn't. The units don't matter.
Yeah, but I always see meters, so it kind of combobulates my mind. Yeah, I'm just saying combobulates my mind.
Literally drop the units.
Yeah, but I'm just saying that's what usually boggles my mind. There we go. 19.
You should have got 20 calculators open.
I have no calculators open, by the way. 19.5. Cool. Oh no. 20 at
Oh, would you believe my slide has an error?
your
19.8.
paste. Okay, now I'm gonna.
Can someone confirm that it's 19.8?
What?
Oh, it says not 90.8, it's 90.8. Is that what you're saying?
Yeah, 19.8, not 19.5.
Copy. Wow, now we've got a lot of dead air. Dead air. Copy. Paste. Copy. Paste.
I'll change that in my PowerPoint.
Uh,
144 divided by 400 equals
No, not doing it that way.
10. 90.8. There you go. I'm going to change it in the
Okay.
original. Oopsie daisy.
Paste. Okay, so that is 1, 2, 3, 4.
There we go.
Okay.
Change it in the original for next time.
Okay, now we have to do it halfway. It would give a. Yep, I was right. About 35 degrees.
How did you get that?
By working it
Like,
out,
what is the maths that you use?
I actually took the angles and I halved it. Well, yeah, almost halved it, and then I measured how it would be with an angle. So is 35 degrees correct?
35 at 300 feet. The answer will be 44 divided by 200 equals, the angle will be 35.7.
There we go.
Right, so how did you get 35?
Like I said, almost double. It's not
No,
exactly
how did
double.
you get it?
Based on this, 90 degrees, I got the distance in, and then let me try and draw it.
Yeah, draw it, we're good. Write down your equation.
But I got the measurement, so that's cool.
Yeah, but then we're going to go to 600 feet, right?
Huh?
And you're not going to apply a linear relationship. This is what we're getting to, Flatside, right? You apply this linear relationship of 60 nautical miles per degree to celestial navigation, but when I'm showing you a triangle in reality, you will not use that linear relationship. That's what we're getting to, just as a spoiler alert for everyone.
So what's 19.5 times 2? About 39. Sorry guys, I am definitely a calculator prone guy, as you guys realized. That's the honesty of what I am. So 39. Oh, sorry, equals times 2 equals 39. And I said it was 35. You know,
I'm waiting for your YouTube stream to catch up.
Can you see it yet?
I could see 19.5 times 2. Where are you getting 2 from?
19.5 is 400. So 400 minus 200, because you're changing your distance, so it gives you 200. And the 19.5 is what you measured at 400. So you times it by 2, which gives you 39. And if you take little discrepancies, you get about 35, like I said.
Little discrepancies of 4 degrees, you get about 35.
Yeah, why not? Because it's optical.
Why not?
Yeah,
why not indeed?
Did I get it right or not? 35 degrees.
35.75, but the
Yeah, but it was
justification
close.
of
But
why
it was
not just
close
take
though.
off 4 degrees is perfection from a flat earther.
Yeah, it is.
Absolute perfection.
It is, yeah. I'm doing it like
Yeah,
this. I'm doing this. I'm doing this way on
yeah,
purpose, because I got I got what you asked for, which you thought I wouldn't get. So I'm not going to show you how I get it, because I have still not got from a tune how to do perspective in orthographic. And I still haven't got from you to tell me that a degree is based on an arc of a circumference. So you guys hold things from me, I can hold things from you. That's how it works.
A degree can be an arc length of a
It's always
circle, yes.
it's always based on an arc. That's what a
Well,
degree
we're
measurement
just drawing
is.
a triangle with degrees in it, right? We're drawing a triangle with degrees
What's
on
a
it.
what's a
There's
rate?
no circle there. I can make one.
Would
but
you
there isn't
would
one.
you agree a hypotenuse is actually just a radius?
No.
Okay, so is the
It's
horizontal
the
a
side of a
radius?
triangle. Like I can make it the radius of a circle.
Oh, great. And you would have
This
a
is such a pointless conversation. But let's just say yes. Fine. Just say yes.
great. So it makes it an angle to an arc. That's an
Fine,
arc
whatever.
angle. What you said, like
Yeah, fine,
like you get
continue.
seconds of arcs, you get minutes of arcs, degrees
Yep.
of arc.
Yep.
Great.
Fine.
So that's where we get our 16 nautical miles based on a flat plane.
Oh man.
No, it's simple
But
as
let's,
that.
let's let the record reflect that Flatsoy just took off 4 degrees to get somewhere near the correct
I haven't
answer,
explained
just
to
for shits and
you.
giggles.
No, I didn't tell you how I got it off, but I got the correct answer. And it's more
Well, show
like
it.
it's more like 3 degrees than 4 because it's 0.7.
Why won't you tell us?
Round off because like
Why
I
won't
said,
you tell me why you
I'll
just
tell
took off
you
4
how I
degrees?
did it as soon as McToon can show me perspective in orthographic view.
Jesus. And you call me a liar, Flatsoy. Unbelievable.
Has McToon been able to show us orthographic view showing perspective convergence?
I will show you how perspective comes from orthographic view. That's fine.
Because this is how I got it to get that 4 degrees about discrepancy. Because I'm taking I can give you a clue. Think of this diagram, and then
Hang on, sorry.
think
Glenn has put it in the chat. The form, where is it? Where'd it go? Someone delete it. Oh no, the formula is distance times the tangent of the angle. Well done, Glenn.
yeah. Think about it. Given a clue, I showed on screen, and yeah, Gleam has actually got it.
Yeah, which you didn't do. You didn't do tan of the
I didn't need to.
ratio.
I didn't need to.
That gives you the answer, Flatsoy.
Did I get
that
the
gives you
answer?
the correct answer.
But did I get 35?
Yeah, but you just refused to say why you took off 4 degrees for some random reason.
I'm literally got on screen giving it sort of in your face saying this is the clue to how I got it.
But please explain why you took off 4 degrees.
Because of discrepancies. Because angle measurements are based
What
in 3
discrepancy?
dimensions.
Oh, Jesus, Flatsoy.
Well, I got the answer, and I don't care if you don't like it or not. I got the answer. That's the thing, because you didn't think I would get the answer.
The fact that you won't show it means either you are clever and you did the trig, but then you know that the trig doesn't work on the celestial navigation. That I'd actually think you were smart if you did that, Flatsoy.
Sorry, what am I
But what
showing
I
on
think is
screen?
someone just told you the answer.
Someone told me
and
the
you
answer.
just saw the answer. And
Anybody,
went, "I'm gonna take off 4
anybody in
degrees." That's what I
chat,
think.
anybody in chat, show me where you told me the answers, please, because this is me on screen here, and
I don't have any.
I worked it out using a tool
Well,
called Keynote. You see, you click on Keynote, and then I
Mhm.
did the angle measurements there. If you don't believe me, you see the bottom there? Oh, back. You see the bottom there? It literally shows my angle measurement.
Yeah. Well, Sean McToon would disagree with you with that.
What's Sean saying?
McToon said, well, he says, Flatsoy's perspective. You don't do perspective in orthographic view. You're asking McToon to do the impossible. Well, McToon claims that he takes perspective into account with orthographic view.
He claims orthographic view is perspective. Sean, it's not my claim. It's his claim. Like when he came on.
Orthographic view is how you derive perspective. It's how you determine what it would look like in a perspective view.
Okay, would you be so kind as to show us in orthographic view where convergence is?
I could, yeah, but not today. I'll do that
No. Come, you made a positive claim, the same claim that McToon made, and then he wanted to reverse the Burnham proof onto me. So, please show us in orthographic view convergence, please.
Okay, let's do
Well,
that.
it's simple. If you draw two parallel lines and an observer, the furthest point you pick on those two parallel lines, the smaller is the angle between those points and the observer. So the angular size shrinks with distance.
Angular
That's
size-
why you get
angular
from
size is not
That's what you
convergence.
get from an orthographic representation.
Angular size
Yeah,
is
I
not
might actually have
convergence.
one done already. Hold on.
Yeah, Bacon, angular size is not convergence. Orthographic view is just simply angular size, but it's not showing perspective.
Yeah, we see convergence because the angular size, the angular separation on the things is shrinking. So if you have railroad tracks, the angular separation between the two lines there gets smaller with distance. That's how you get convergence.
Well, let's see what Ruaf brings up and we can see.
What the fuck? Hang on. Where's mine? Sign in.
By the way,
Sign in.
renders that render with perspective are derived from those orthographic representations. I wrote them myself.
Oh, here we go. This will do. All right. Yeah, it's pretty much just what Bacon said. If I move further away from something, the angular size of it will get smaller. So the angular size there on screen gets smaller as I move further away.
So
if I
not
had several
convergence.
goalposts here,
So show me the
they would
convergence,
converge into
please.
each other.
No, show me the convergence, please. Angular size
Yeah,
change is not
just explain it in
convergence.
words.
Angular size change is not convergence. Do you know what convergence is?
Yes, it is. when the angular size of something, between 2 points, so let's say these, the top of the goalpost and the bottom of the goalpost, they will converge together as I get further away.
False.
All that means is the angular, what?
False.
Did you say false?
They get smaller in angular size, not converge.
Wait, let me. Now I'm about to do math. Fuck. So, tree 150 feet tall. You're 400 feet away from it.
Yes, but I've got an observer height of 6 feet, so you got to take that away. So it's 144 feet above the horizontal.
Ruth, what is convergence when it comes to perspective?
Your fucking fight, but pardon.
Are you roboting on me?
Yeah, he's roboting. Ruth,
Okay.
what is convergence?
Yeah, the angular separation between them getting smaller.
No,
with
that's
distance.
not convergence. I don't want your own
What do you
definition.
think convergence is?
I don't want your own definition of convergence. What is convergence in perspective?
I just gave it to you.
No. Convergence is the apparent conjunction of the objects converging to a point, correct?
Right. They get closer together as you get further away.
They're converging to a point, not get smaller in
Okay.
angular size. Now, with perspective, you have what they call eye level, correct?
You have eye level, sure.
Okay.
I'm
Will you
confused why you think
draw?
that's my
Will you
definition's wrong.
draw? Will you
Yeah,
draw
why do you
eye
think that's
level?
wrong?
Will you draw eye level in there quickly, please?
The fact that he puts eye level in there kind of screws it up, but your angle from your eye level going up to the top of the tree is 19.8.
Yeah, he already corrected it though. Lotion.
Well, where did 35 come from?
That was based on the 19.5. We just left it at 945 and I got it like that. But it came out to like 35.7 or something. Okay. So, do you see that eye level changes relative to the top of the goalpost and the bottom, correct?
Right.
Okay, which one is converging? The top or the bottom?
What?
Raise your eye level just a bit.
Okay.
Okay, just till there. Which part is converging to eye level?
This part, the bottom will converge quicker than the top.
Okay,
As I
just
move away.
carry on moving away. In the same level.
Yeah.
As far as you want. Staying the same
Alright.
level. Show me where those. Okay, take a second there. It's fine. Now go back to where you were by
Can
the
you tell me the
goalpost.
new dimensions too that you're going by?
No, this
How
is
far you are? and
this
how
is
far
just no.
something is?
This he was taking to 200 feet away. Okay.
200 feet from what?
He was 400 feet
Yeah,
first.
three.
He was first 400 feet,
We're
then he
doing two
went to
things at
200.
once.
Yeah. Okay. Yeah. So zoom in there, Roof,
Into the goalpost.
into the goalpost.
Yeah.
Is it still showing the same conversion?
The angular size is smaller, yes. The separation
And the
between them is
conversion
smaller as you
to,
get further away.
and the conversion is still saying exactly the same.
What? What are you talking about?
Oh, maybe I should draw it for you. I don't know how must I explain this? It's so simple.
I agree. The further away I get, the smaller the angular size
This is
gets
a
between those
goalpost.
2 points. That is convergence.
Okay, this is a goalpost. Let's
How about-
say
can you
this is
share
the eye
your,
level.
Share your screen on Discord.
I
so I
can
don't have to wait.
try. How do I share your screen? There we go. Is it showing? Or must I say
On the
go
YouTube
live?
stream, yeah.
Can you see it on YouTube? Because I don't want to say go live or something. Should I say go live?
Oh, there we go. There we go.
Okay, it's showing on. Okay, it's showing on there as well. Anyway. So, that's your eye level, that black line. That's the goalpost. This is the. Okay, well. Okay, that's the eye level. Okay, let's get a new line to say this is the ground. Parallel, correct? Okay.
Yep.
Now, let's have you having an. I'm just gonna say my eye is grey here, whatever. Here to the goalposts. That's eye level. Now moving away. Do I have the same eye level?
Right.
Where's the convergence? It's staying exactly the same relationship to the posts.
No, the angular size when you get further away is less.
The angular size
How
gets
simple
less.
is this?
The convergence stays exactly the same. This eye line stays
No.
exactly the same in orthographic. It never changes, no matter the distance. Oh, so you're saying this is different to this, based
Yeah, the
on
angle from each observer to the top of the goalpost, as you move further away, that angle will get less. The elevation angle will get less.
angular
Same
size
with
So
change.
he's saying to
angle
the
to the
top of the
bottom.
goalpost, but he's not saying eye level with the
Yeah, he's not understanding.
Oh,
Angular size change is not convergence. That
Hmm,
angle
yes, it
size
is.
change. No, it's not. Are you telling me that this parallel lines are converging? Remember, this is the ground.
If
This-
you move further away, right,
Let's
and
move
you,
further away
you
again.
point two directions to them, that angle will get less. That's exactly what's happening.
Let's do this. There's an angle,
Yeah.
correct? To the
Yeah.
goalpost. Same elevation. There's an angle
Yeah,
to
but that
the
angle-
to the
yeah.
goalpost. Look, no, to the goalpost.
Yeah.
Correct? Same convergence line. Okay, back again, another same convergence line,
But-
angle to the goalposts. The convergence, aka the eye level, stays exactly parallel to the ground, no matter the distance, correct?
Right.
That means this distance stays
Yes.
exactly the same always.
Yes.
So
But
where's
what
the
do you think
convergence?
convergence is?
The convergence
What
is
do you
that
think convergence is?
the apparent ground would rise relative to eye level, correct? And as
That's reflected in that angle. The observer on the left, the angle to the
are
ground.
you this fucking
is
dumb?
closer.
I'm sorry for the swear word, but are you this dumb? The eye level remains exactly the same eye level no matter the bloody
Right.
distance you travel. The convergence would mean the ground would appear to rise relative to eye level, and the goalpost's top will sink relative to eye level. It just changes
Yes.
angular size. It's not
That's
change.
reflected.
Show me the ground. Show me where the ground is converging to eye level, yeah, please.
Yeah, by your smaller angle for your left observer.
I'm sorry.
When you say the ground ramps up, you're saying the depression angle gets closer and closer to zero.
Is this guy?
You understand that?
You literally are not providing evidence where the ground is converging to eye level, no matter the distance.
Yes, the depression angle from that observer gets less and less. It approaches zero. It approaches horizontal.
You're making your own bullshit
That
up, as
is
Taylor says.
convergence. Holy shit.
No. Let's
I think I'm done, Flatoid. I think I'm done.
Yeah,
I gotta
you
go
are.
next.
You are
No,
done.
I think you're.
You've been done for the last half an hour.
Yeah.
He's retarded.
Okay. Thanks, Flatoid. It's been great. People are going to clip out
Look
some
here.
fucking crackers from this one.
Railway
Absolute crackers.
perspective.
All right, I'm running away. Running away.
But
See you later.
okay, let's look at a picture while he's gone, guys. Let's look at this picture because
What a
this.
douchebag.
Yeah, he's an idiot. He's a moron. On live show, guys, he literally did flat Earth navigation. He said was impossible to do.
Yeah, nobody likes Ruhe Lucian. He's a condescending prick. I'm sorry, but he is.
Okay, you guys can see on my screen, correct? Oh, I may
Yeah.
have to stop sharing on.
But
The
you think
Richard
that
Keith is-
magically that your eye level is going to reach horizon.
No, but
It's not
he hasn't
practical, it's not
provided. He hasn't provided orthographics showing that because the parallel stays
Yeah.
exactly the same parallel no matter the distance.
Perfect.
Okay,
You just
on
simply
screen,
perfect wrong
on
every
screen,
time.
on screen. I'm literally showing a railway. Now, the angles are converging to a convergence zone, to relative to eye level. So it looks like it is going to a point, correct? It looks like it's rising relative to eye level and going to a point. Correct. That's convergence. So if I raise in elevation, that railway is still going to converge relative to eye level. So now, on his orthographic view, how is he providing me that the ground is raising relative to eye level? He hasn't. He drew out angular size change and calls it convergence.
God, optical illusion.
Exactly. Orthographic view is
They love their
two-dimensional.
optical illusions.
Yeah, guys, it's really simple. Perspective is three-dimensional. Orthographic is two-dimensional.
And Sean was trying to tell us what that McToon was saying. We know exactly what McToon was saying. He said it here. You know what I mean?
Okay, let's recap, guys. Ruoff made a claim that you cannot do celestial navigation on a flat Earth. I got him to do it for us and to use any map because I don't care what map he used. He conceded. It did work. He got a fix.
Yo, a wrong fix. How
It
does that
doesn't
work?
matter. He got a fix. So, in other words, he did celestial navigation on a flat Earth.
Oh, but the claim was never that you can't try. The claim is that you can't do it and got it working.
The claim is you cannot do it on a flat Earth. He only used.
No, of course you
all
can
the-
do it. It won't work.
Okay.
That's the claim. Obviously.
And then you guys conceded when you change the map, you get a different fix.
yeah,
correct?
but
Okay,
they're
great.
going to be wrong. Yeah.
So
They're gonna be
so
wrong
it's the
if you're-
map. So it's not the method and the data that's wrong. It's the map you use that gives your discrepancy on how
No,
close you are. Correct?
There's
No,
incorrect.
correct.
There's no
Correct.
incorrect. No,
You just
because
literally
doesn't
said
matter
yes.
which I just what?
You just literally said
I'd
yes.
like to try to get to the end of my sentences when we're talking,
Okay.
if that's okay. Right. It doesn't matter which map you pick. If the circles work on a sphere, they can't work on flat Earth. They can't work on a flat map and on a sphere at the same time. So it doesn't matter which map you pick. They're always going to fail if you're drawing circles of equal altitude on flat maps.
Again, you can get a fix on any map. You can get a fix on a pineapple if you want to. It's not about the discrepancy. It's about the claim you cannot do it on a flat Earth. He used what? Flat Earth data to get his fix. Now, you guys conceded if you change the map, you get a different fix with the same data. The data being flat. Your globe is based on flat data. And Ruoff...
What is data?
What is data? What do you mean, what is data?
I never heard the word.
It's information.
Information,
data.
yeah. You
Okay.
literally, your program you wrote is based on data, is it not? Or data, as you like to say. I'm South African, so I
Right.
say
Oh,
data.
that's the first way I heard someone pronounce like this, so it didn't. I
Okay.
wasn't. Didn't
But
want
you
to
would
listen.
agree, you have
That's
to
a
put
point.
information into your program to write it.
Sure.
Yeah, so that's the same with celestial navigation. The information is based from a flat horizontal plane. You're coming later on and
Right.
applying that information on a map comes after already having the information on a flat plane. So even him drawing it, Protothat drawing it on that globe, came from flat plane measurements. That's the whole point of the argument.
Right, but here's the thing: if those circles intersect at the right location, when you're drawing down on a sphere, once you flatten that sphere, it doesn't matter how you do it. Those circles are no longer going to intersect at the same place.
They won't intercept at
So
any
you
map the
can't-
same.
Sorry?
Again, you're not understand. You're literally running away from the data. The data he used was flat. So therefore, I don't care about the discrepancy.
What
how
data?
far away?
What data was flat?
90 degrees, horizontal elevation angles. All the data he's used is based from a flat measurement, an angle from a horizontal baseline. You first start off flat. Then you take that data and stick it
I'm
onto
not
a
getting-
coordinate system, and you work your circles off from that coordinate system. That coordinate
I'm
system
not getting what you're
gives
saying.
you values to your globe afterwards. So the globe comes after flat.
Okay. What flat data are you talking about?
What do you mean, what flat data? Did Ruef have actual measurements and distances?
I don't know. I think he just plotted the values you gave him.
Yeah, so if you plot the values, it's based on a flat measurement.
Oh, what do you mean a flat measurement?
Oh, let's do it like this again. I measure 45 degrees to a star. Let's say Polaris. I take it, I know
45
it's
degrees of
45 degrees.
One second, just to clarify. 45 degrees between the star and the horizon?
Yeah, you measured 45 degrees from Polaris. You standing, you see Polaris, you measured 45 degrees, correct?
Okay.
Okay. Now, I know that's based off of a 90-degree angle. So I
What do you
take
mean?
45. It's based on a right angle triangle, so the base is 90 degrees.
Wait, what? I mean, if I measure the angle between the horizon and the star to be 45 degrees, where are you seeing a right angle triangle there?
That's what it is. It's a right angle triangle. The 45 degrees comes from the 90. So, when you go, take the...
Why?
Why? Because it's a right angle triangle. It's an hypotenuse
Yeah, why,
of a
why
right
do
angle
you think
triangle.
that?
Because that's how celestial navigation works. Right angle triangles.
No, it's not. But let's just assume it is.
Okay, go, show
And
me a
try to
citation.
understand.
Show me a citation in celestial navigation that does not use right angle triangles, please.
I don't think people write about
Every
what celestial
single-
navigation doesn't do.
They use
Uh,
triangulation based on right angle triangles. That's what celestial navigation is.
Okay, so let's do an example, shall we?
Okay. Are
So
you,
if
are you
my
going to share your screen?
right,
Okay.
sorry.
Are you going to share your screen?
Yeah, we can do that.
Okay.
Let me. I think I use my simulator.
Guys, I can't believe it's already 1 o'clock.
I know. After last night as well.
Oh, man. But I am enjoying this, though. I'm going to be sitting in church tomorrow, later this morning. I'm going to be like,
Yeah, you get the work and just fall asleep. Listen, I think the last time I went to church, I probably fell asleep anyway. It depends on the pastor.
At least we sit outside because of my daughter. She struggles to stay still because she's still young. She's almost 2 years old, and it sucks.
I bet it's roasting in the church building where you're at.
No, it's okay. They got aircon, but we sit on the outside. But it's funny because it's my wife. Otherwise she's always in the mother's room with her, and then I'm sitting
Yeah.
alone anyway. So now we all sit outside, us three, while the other two are in Sunday school, and we listen from the outside, so she can still play and do her thing and stuff.
That's good. Good.
So if I do fall asleep, people are gonna definitely notice. Are you going to get Polaris at 45 degrees?
Now I'm gonna get canopus.
Okay.
And I'm not sure what angle because I haven't measured yet, so I'm gonna measure right now.
Okay, cool. Yeah, it doesn't matter which one you get though.
Aren't we gonna have discrepancies anyway? Because if the stars lay on a dome, then that's curved and the Earth's flat. Wouldn't there be some
I just got
discrepancy?
Wait, yeah, definitely. But I just got to say, Lotion, look what he's doing. He's moved the star down to the horizon, correct, Bacon?
Yep.
Okay, cool. It's a good start.
Right. So I can get the elevation angle now, which is right there. I'm just gonna screenshot it.
Okay.
And I'll drop on the chat so I don't lose it.
Okay.
Okay, so what do we do
What's
now?
the elevation angle?
The elevation, well, the angle I measured was 35 degrees and 24.3 arc minutes. As you can see on the screen, this is the elevation angle, the section angle. I mean, it's not an elevation angle yet, right? Because we have to subtract dip and we have to correct.
You still
for
have to do the
refraction.
corrections, yeah.
Right, so let's get another star. Might not be easy to find another one now. Okay, so this is Sirius, that's Canopus.
But you do understand what you just did by bringing it down to the horizon, correct?
Yes, I measured the angle between the star and the horizon.
Cool. So you understand it's based on the horizontal, a 90 degree.
No. No, there's no horizontal.
What is that
there.
35
I mean, the
deg-
fact that
What is that 35
the
degrees? What is that 35 degrees you just measured? Was that based off
angle between the horizon, it's the angle between the horizon and the star.
Great, so a 90 degree baseline. Congratulations.
No, wait. What do you mean a 90-degree baseline?
You got a
90 degree-
horizontal baseline, which is measured to 90 degrees from your zenith.
Okay, so I'm not gonna do any dip correction then?
No,
Because,
you
my
still have to.
baseline is already.
You still have
One
to because
second.
you still have to because your eyes are not embedded in the ground.
Right, so my baseline isn't horizontal, right?
Oh, yes, it is.
Otherwise, the angle, dude, gotta let me finish my sentence. If my baseline is already horizontal, my angle is already an elevation angle, isn't it?
Sorry, say it again.
If my baseline is horizontal,
Yeah.
then my angle would already be an elevation angle.
Yeah, and do have an elevation angle, but you have discrepancies because you're looking in three-dimensional reality. Hence why you have to do your depression angle or height of eye correction and refraction.
That's not the elevation angle then, is it?
You got an elevation angle now, didn't you?
No.
You
That's
don't
the
have an
height-
elevation.
height
So
of
you
the
didn't
section.
measure
That's the-
30. So you didn't measure 35 degrees now.
Yeah, but that's not an elevation angle yet. I still have to do some corrections before I can call that an elevation angle, because an elevation angle is off of horizontal.
Sorry, it's still an
I didn't
it's
measure off
still
horizontal.
it's still an elevation angle. When you pick up your sextant and you're looking out, are you holding your sextant vertical?
Kind of, not perfectly, but close to it.
Yeah, you're holding it vertical. Let's take like the old Kamals. They used to use a plumb bob. Why did they use a plumb bob?
Okay, I'm not using a plumb bob here. in
Yeah,
the
but I'm saying
simulator,
like the
am I?
old
I'm
Kamals.
simply
The sextant is
measuring
based.
angle.
The sextant is
Simply-
yeah. The sextant is based like on the old Kamal where they used the plumb bob. And you had to bring
try
the
again.
star down to the while you're looking for the star, you had to bring the star down to the horizontal. Correct? Because you had to mirror. You had to get the two mirrors to line up the angle, which would be parallel to the horizontal, the horizon. The horizon is horizontal. That's your horizontal baseline. So as soon as you brought it down to the horizon, you brought it down to your horizontal. Remember what I said in the sextant works on succession angles?
You know what?
That's the principle of the sextant. It works with the succession angle measurements.
Trying to get.
I mean, you
I think this is
literally,
something else.
you literally started off with proving my point when you brought it down to the horizon.
No, the bringing it down to the horizon is measuring the angle between the horizon and the star. That's all
Is
I'm doing.
35 degrees minus 90 give you a co-altitude angle? If you didn't even do height of eye.
No, because that's not my altitude angle. I gotta correct for dip first.
No. You still, even
Yes.
if you don't do dip correction and refraction correction, can you still get a co-altitude angle? It won't be as accurate, but can you still get a co-altitude angle?
Yeah, if you assume that that the angle you measured is in altitude, then yes, you can subtract 90 and get the altitude.
So 35 degrees measured is not an apparent altitude angle. Is that what you're telling me?
No, it's the height of the section. It's the angle, the raw measurement.
Which is an apparent altitude angle, which is based on elevation angles. Just
No,
because
it's
you
not an altitude angle because they're not measuring off
can
of
you
horizontal.
can you show me a citation where it says measuring an apparent altitude angle is not an elevation angle?
I'll give you the citation to explain the name of the angles we're talking about so you don't get confused anymore. Just give me 1 second. Okay, I'm opening right now. Basics of okay, HS is section altitude.
Yes.
Let's see. You have HS, which is the section altitude. You have HA, which is the apparent altitude, which is the one you're talking about. So how do you get from HS to HA? Let's see.
HS comes after after your changes of discrepancies. So the corrections.
No, that's the HA.
The HA comes after the corrections, exactly.
Yeah, some of them. The dip correction in the index error.
But are they taken from the HS that's already measured an angle?
The one you measure is this one. First one, HS, section altitude. That's the
Okay.
one you measure.
What is altitude?
That's not enough.
What is altitude?
It's just how high something is.
So elevation then?
Yep, but this is not an elevation angle yet.
It's still
This
an
is just
elevation
a raw-
angle. Just because you say it doesn't say elevation angle, it doesn't make it not as. Even Ruif
Right.
literally says it's an elevation
By
angle.
definition, an elevation angle is off of horizontal, not off of the horizon, off of horizontal. The section altitude, the first angle, the one you measure, is off of the horizon. After you correct for a dip, then you get it off of horizontal, which is the second one, the apparent altitude. And then you correct for refraction, and you get the observed altitude. Does that make sense?
Still based off elevation angles. That measurement
Yeah,
you
the
take.
second one is an elevation. The second one is the apparent elevation, and the third one is the corrected for refraction elevation.
So it's still an elevation
Interrupt
angle
for
then.
1 second.
Sorry?
Let's interrupt for 1 second.
Yeah, go ahead.
So just in the chat, Lumpy Gas in a Vacuum calls me a clown. I call him a clown back, and I get timed out by some pussy in the chat.
Yeah, it did tell me that.
You got to look after your mods there, Flatoid.
Congratulations, guys. He's coming to play victim now. You know what?
Yeah,
You
no,
know
I
the
think
sad
that's
thing. You know the
cool.
sad
I
thing
think
is.
you're a condescending prick, Ruif. That's why I timed you out. You're a condescending prick. Simple as that.
Ruif, I'm glad you came back though.
Alright.
Can you
Are you
please?
going to
Can you
ban?
please?
Are you going to time out Lumpy
Can-
Gas in a Vacuum?
No, I'm not.
No, I'm not going to tell
Or are
you
you going
that.
to show
Lumpy
that you
gas,
have?
but he's a mod,
unfair
so how
moderation?
can I tell him that?
How
People don't stick around.
How
Moderation
about
shit, right?
how about you stop playing victim, and now that you're back, can you please explain to Mr.
Well,
Bacon
but
what an
make it
elevation angle is? I'm trying to look for your DM with the elevation angle.
Let Bacon finish what he's doing first.
He's looking for the star song. While he's doing that, you can explain elevation angles to him,
alright.
because he seems to think there's no elevation angle when taking your measurement.
With a marine
No,
section.
I said that it's not an elevation angle before you correct for dip. It's just the section out or the raw reading. Once you correct for dip, because that's not off of horizontal yet. It's
Where
off
is
the
it?
horizon, which is not horizontal. Okay, so he's saying there's a right angle triangle somewhere. I'm trying to see what the hell he's talking about.
Have you managed to get your star yet?
Oh, backward. 31st of May, 2021.
I'm looking for your elevation angle thing that you sent me.
Can you see
Can't seem to
my
find it. Okay, well,
drawing?
well, let's just get back to this though.
Right. So let's see. I measured. Oh, 1 second. So the angle I measured is let me see. Dropped on chat. It's 35 degrees.
Yeah, 35
Question
degrees.
for Bacon, actually. Is it an elevation angle before or after the refraction correction?
It's always an elevation angle. You elevated, are you not? Because what's your argument, Ruif? It's not an actual horizontal. The elevation angle is your horizontal reference, correct?
Elevation angles are reference to horizontal, yes.
Great. So when you take a 35-degree angle like he just did, that bottom line is an elevation angle, correct?
Not the bottom line, the angle between the horizontal and whatever you're looking
That
at.
elevation, that hypotenuse based on the horizontal is an elevation angle.
Not a hypotenuse, it's not a triangle.
Celestial navigation works with right angle triangles, Ruif.
No, it doesn't.
Yes, it does.
No, it doesn't.
Then why is it giving you the GP to the star and a distance to the observer's GP?
So you can draw a circle on a globe.
No, so you can complete the triangle. So you can complete the triangle.
Not a triangle. It's not a triangle. Do we need to go through the trigonometry again?
Okay, that's got the L. I'm gonna get.
Is that a triangle? Is that a triangle, Ruif?
A spherical triangle,
So it's a triangle. Is
triangle.
that a triangle, Ruif? And is that...
That's not a triangle. It's got a curved arc at the end.
The arc? Okay, let's look for one that doesn't have a curved arc. Because you know that curved
and
arc...
it's at the center of a sphere. Do you want to call that a triangle? Do you want to
You saying there's no triangle at the center of a sphere? Is that what you're telling me?
Are you claiming that celestial navigation works off a triangle based at the center of a sphere?
That's how it works, yes.
No. On the surface of the Earth, right? It's not a right angle triangle.
Okay, Ruif.
I thought we figured that out with the tree graph.
Ruif. Okay, Ruif, that star to the observer, does it sit on the same GP on the same equatorial plane to the observer?
Stop using the word equatorial plane. It's not on the same plane.
That's what that is. That's an equatorial plane. I know you have a hard time accepting it, but an equatorial plane to make your triangle is the truth for celestial navigation. I don't care if you don't accept it. That's just how it's done. It's a triangle. They do triangulations with triangles on a globe, apparently.
You keep misusing the term equatorial plane.
Okay, what's the equatorial plane?
The plane at the center of the Earth that runs around the equator.
Great. So when you make a measurement, you've literally done this on your own channels, Ruif. When you've taken a measurement and you duplicate that angle to the center of Earth, that would be to the equatorial plane, correct?
The declination of a star is relevant to the equatorial plane, not your altitude or elevation. Just say the word plane, right? If your observer has a horizontal plane, it is not the same plane as the GP's horizontal plane.
Prove it. Prove it.
You say they are. I say they're not.
Prove it.
The fact that we get a correct fix on a globe tells you that.
No, prove it, because I'm literally showing it on screen now that it's on the same plane.
There you go. So your observer's at the center of the Earth?
No, that's how you do your math. Bob, not the science guy, does it. That's how you do it. That's how McToon does it.
You've got a spherical Earth there.
Show me, yeah.
This is the onboard intelligence picture that you're showing. You've got a spherical Earth. Why are you why are you showing me spheres?
Check here. I got another one up for you.
Right.
I've got 12 miles off.
Oh, he's still busy with that other bacon? So you use the
Yeah.
Mercator map now?
Yeah, let's
Wow.
let's do the math for a
No.
GP.
Before we do that, let's first go. While you're back. What is this?
What is what?
What is right ascension?
It's
It's,
the equivalent of longitude.
Sorry?
Yeah, but on the celestial sphere.
Yeah, it's
Sorry?
longitude on the celestial sphere.
Great. Okay, and is that the same plane?
It's not a plane, it's a sphere.
Right ascension, longitude.
Those are analog. Analog.
But let's just give him whatever bacon, and we'll do the actual.
Okay, what's the difference
trigonometry
between
for a
longitude?
triangle.
What's the difference between longitude and latitude?
I don't know. I think that's too obvious. Why are you asking that?
Sorry?
Yeah, don't ask questions everyone knows the answer to.
No, I just want to say, what's the
Everyone
difference
knows.
between longitude and latitude? Which one is which?
Okay, latitude is the distance to the equator, and longitude is how off you are from Greenwich line.
Great. So a azimuth, you would agree, it detects your longitude on a equatorial plane.
Huh?
I literally got on screen here for you guys to make it as easy as possible to understand. You see this circle, this disc, you
I
could
can
say.
see your screen.
This disc, you could say. That.
I don't see your screen.
It's on the YouTube stream, like 30 seconds.
So
Can you share your screen? I mean, your
okay,
screen.
I can try
so we
share it
see
quickly
that.
for you. Let's see if I can share screen again.
You fix that meme.
Go live. Okay. There we go. You can see it now, correct?
1 second. Yep. Can see now.
Okay. Is that a sphere or a circle? Is that a plane, guys?
That looks like a circle or a plane.
Great, so it's a plane. Is that a triangle on that plane?
That is a triangle, yeah.
Great. So P has a GP to the same plane as observer on his GP. They have the same plane together, correct?
On that drawing, it seems so, yep.
Great. That makes a triangle, correct? Which Ruth said doesn't use triangles.
Celestial navigation, it's not a triangle between the observer, the GP, and the star. It's not a triangle, not a right angle triangle. That's what I'm saying.
That's what celestial
We'll get there,
navigation
let's
is. Celestial navigation is
Well,
based
let's
on
test
triangles.
it then. Let's test it.
It's on screen for you to test.
I
How
will
do
do the test.
how do you get a right ascension angle, correct? If it's not on the same plane, Ruf?
We don't get a right ascension angle. That's just the mapping of the star. It's not something
Yeah,
we measure.
but but is a right ascension? It's a mapping, correct? Over the same plane.
No, maybe on your drawing.
If you
that's
get
not how
it, if
use
you okay, try and do it then without the same plane. Let's see if we'll get it right.
Yeah,
Map
I'll
it.
show you how we do it.
This
So,
is how you do it.
this
It's
is not
measured
how I do
east.
it.
Okay, must I stop sharing my screen? Where's my stop sharing? Okay, let's see yours. Oh, using Google, the Earth. Okay,
This
you
is
got
on
the.
Google.
I know, I can't see.
This
You
is
just
on
got to
Google.
Earth. You just got to Earth. Yeah. So, are you claiming there's no chord?
Including what?
Are you claiming there's no chord on this?
What do you mean chord?
A chord cuts through your Earth to have the same plane.
I'm not using any chord. Let me see what's the right location is. So latitude. And this is the longitude. Oh, right there. So that's the location I am in the simulator.
Yeah.
Those are the circles of equal altitude that I get.
Okay.
And that distance between that intersection and that point is about 12 miles.
Okay, still not telling me how it's not on the same plane.
Right. Okay, so the stars there are over their ground positions. If I turn on this latitude and longitude grid.
Yeah, because it's coordinate system, like we established in the beginning.
Okay. 1 second. Okay, so each star here is in a coordinate on that sphere. So if you go here on Greenwich line, just this line here, as you go right, you get the right ascension. So this star here, Alpharet, I'm not sure how to pronounce that.
Yeah, that's good.
Would be, sorry?
That's good.
Yeah.
Right, would be like 2 degrees and some, I don't know.
Let's say 2.2.
20,
Let's say 2 degrees and 20. Yeah.
This would be the right ascension. I mean, actually, we use hours instead of degrees, but it's the same thing.
Yeah.
Instead of
and that is that on the same longitude line?
What do you mean?
Is that on the same longitude line?
That's what.
The same of what?
To get your coordinate measurement. If you had to move it more to the right, in other words, would it be on the same longitude plane?
If you do what?
Let's move the star, let's say it moves more to the right. There or to left. Is it following the same longitudinal plane?
No, it's following the same latitude.
I mean latitudinal plane.
You could say so.
Great,
Yeah.
so it's the same plane. That's how you get your azimuth, correct? Over the plane.
No.
If I'm saying if you need to get an azimuth, you get it over the same plane as your GP to the star. You're literally making my point
No.
on screen, mate. You're moving it over the same plane.
No, you're not using azimuth. How are you coming with azimuths now? We didn't mention azimuths once.
Azimuth is based on the same plane. That's why.
Yeah, if you measure an azimuth to that star, it's a horizontal angle to that star.
On the same plane?
But when you're horizontal.
Yeah, great. So, one horizontal plane. Thank you. It took so long just to say that. Congratulations.
But that has nothing to do with all your
so you got a triangle.
That has nothing to do with
so you got a triangle over a horizontal plane. So the same horizontal plane, the GP of the star would be on the same horizontal plane of the observer. A triangle on a horizontal plane. How much longer are we going with this?
If the star was in the same horizontal plane as the observer, I wouldn't be able to see that above horizontal, right? It will always be at 0.
What are you talking about? The star is always above you. Your apparent angular measurement determines how far it away is from you on that horizontal you are observing it from.
On the Earth.
No, you are standing on a horizontal baseline. That arc measurement you're making is based off of a triangle from a horizontal. You just literally said it's on the same horizontal.
Now, if
it's on a globe,
you are turning those two lines into a triangle because you want to. That's not necessary for the measurement. It's just something you're adding there, and it's not making sense. It's not helpful.
A circle of equal altitude has the same altitude, correct?
The circle doesn't have altitude.
The GP of the star is the same planal altitude as the GP from the observer.
That question didn't make sense to me.
How can I try and explain this? You have a flat plane. You measure out to a star. Okay, that star has a GP. Okay?
What is my flat plane?
You measure 35 degrees to that other star, correct? What is,
Yeah.
how do we get the co-altitude angle? After we've done now the corrections, obviously for height of eye and refraction, whatever. But let's say you've done that and you still just measured a flat 35 degrees. Okay. You take 90 degrees, and you minus that 35 degrees, and that's how you get your co-altitude. That's how you get your co-altitude angle. That co-altitude angle is the measurement of the apparent star's location based on the same horizontal plane of the observer. I'm trying my best, Taylor. I'm trying my best, Taylor.
That's your claim, like okay,
you
so
literally got
here's,
it on screen now. You literally got it on screen now. What is
Yeah, I'll explain why
can you have
doesn't make any sense.
can you have 35
Go on.
degree measurement without having a 90 first?
That's the raw angle. You're just measuring that. You don't have to establish a 90 to measure an angle between two things. You can just point the two things and get the read. Don't have to establish any 90. That doesn't make any sense.
Can you have a 35 degree angle if there is no 90 to establish the 35?
Sure. Any you can always get an angle between 2 points that you can see without establishing anything.
Okay.
What do you mean you need a 90 to measure? Like, if you measure the angle between two stars in the sky, what do you mean that you need a 90? What does that mean?
35 degrees comes from a 90. This guy has a zenith.
What,
Correct.
What do you mean comes from a 90?
He's literally drawing it on screen for you.
Hang on, let me check screen. Bacon screen.
The observer's zenith,
say it comes from a 360. Like, what does it mean?
the horizontal is perpendicular to the vertical.
Right.
That's a 90 degree. That's a 90 degree angle, Ruhaf.
Right, but the elevation angle is between horizontal and whatever you're looking at.
Again.
That doesn't require a 90, that's just...
You
just an
literally
angle.
just drew 90 on the screen. A 90
Yeah, you
degree
can do that.
angle. So the 35
the
the 35 degree angle is based from a 90 degree angle without the having
Could
your
just as easily say,
Okay, get
just
this-
as easily
okay.
say that it's based on a 360.
Okay, then I'm going to do this. Ruhaf and Bacon. Don't use it. Don't stand at 90 degrees. Lie on the floor sideways, or at any flippin' arbitrary position you want to. Heck, show the sextant at your butthole and show me how you get 35 degrees of that star, please.
35 degrees between the star and what?
Exactly. Between the star and what?
That's
You
on-
are
horizontal.
90 degrees to the star. Yes, this is...
You need a 90 to triangulate.
You need a 90 to get a co-altitude, but you don't need a 90 to measure the angle.
So the guy's not standing 90 degrees.
Horizontal is by definition perpendicular to up
What
and
is
down,
what is
sure.
the first thing you do when you have the stars in your mirror? Bacon did it. He brought it down to the horizontal, correct? To the horizon.
To the horizon.
90
And then have to
degrees.
adjust back to horizontal.
90 degrees.
Yeah, it seems to be
Yeah,
a bit
the 90,
semantic.
the only
I don't get
90,
it.
the only 90 degrees here is between the zenith or the vertical and the horizontal. You can see either of those. You can
So
only see the,
you're bringing
your
the
baseline,
star. You
which
bring
is not horizontal. Let me finish, please. You can see your baseline, which is the horizon, which is not horizontal, and then you adjust for horizontal, and then you correct for you do the 90 degrees because there is a 90 degree between vertical and horizontal by definition.
So the guy
That's the 90
observing
degree, right here.
you observing the star is 90 degrees. You standing vertical to horizontal.
No, listen, Plato.
Are
We're
you
measuring
standing?
the angle
If you're
between
standing,
the star and the horizon.
are you
that doesn't
claiming?
require
Are you
90
claiming?
degrees anywhere.
Are you claiming standing upright is not a 90 degree?
We can measure stars in the sky.
Are you claiming
that are
when you
sideways,
are you
right? We can
claiming?
measure that angle.
Are you claiming?
Sideways.
Roof, are you claiming even when you're sitting now is not 90 degrees?
We're getting semantic bullshit, Flatzoid.
Are you claiming where you're sitting now is not 90
I'm
degrees?
sitting upright, but the angle between two things in the sky.
You are throwing
doesn't
away.
need a
You are
right
throwing
angle.
away trigonometry here, Roof. 100%.
Jesus.
You sitting in your chair is 90 degrees. Are you saying a zenith is not real on your globe anymore?
No, Flatzoid. Not Jesus Christ.
Are you
You
90
try and make
degrees?
these ridiculously stupid semantic
Okay,
points as if
I'm
you
not
like
going to
win
talk
an
to Roof
argument.
anymore. He's
It's
dishonest.
bad.
Bacon?
No,
Would you
it's full of
agree?
crap. Full of
Bacon?
crap.
Yeah, Bacon, would you agree that you are sitting in your chair now 90 degrees? You're sitting upright. Upright.
Oh,
Your
really?
zenith.
I don't sit in a.
Neither do I. Don't sit upright.
I'm almost laying down on my chair.
Okay, what's a zenith on your
Yeah.
globe? What's a zenith?
Zenith is up and down, Flatzoid.
Is
Why
your
are you asking these silly questions?
is your head zenith and your feet nadir?
Sure. Let's just give him whatever. Like, whatever, Flatzoid. You win this semantic bullshit debate, whatever.
Okay.
Let's continue.
This guy's standing on the boat. His head is zenith. His feet is nadir.
Okay.
That is vertical,
Okay.
correct? He's standing vertically up.
Okay.
Like any normal
Yep.
human being in reality. He stands up.
Yep.
Is that a
Yep.
90
Continue.
degrees?
Speak up.
What is
Sure. Yep.
That's 90 degrees.
90 degrees. Yep. Perpendicular, horizontal. Perpendicular, up and down. is horizontal.
Awesome.
Done.
Great. Now he's taken his sextant and he's measured 35 degrees from a 90 degree.
No, he doesn't need a 90.
So the
He's
guy's-
just measuring the angle between a star and a point on the horizon.
This is so
Doesn't
frustrating.
need a 90.
You have no
Doesn't
idea
need
how
it.
frustrating this is. The guy is standing upright. He's standing upright.
Okay.
His head is upright.
But like I
You
said,
literally
we can measure
agreed.
angles between two
literally-
random stars in the sky. Do you think that requires a 90?
Yes.
Why?
Okay. A sextant.
Why does that require
A sextant
90 degrees somewhere?
is a sextant a triangle of an internal sum of 180 degrees. Riff?
Sure.
Sure. Yes, correct. So, using a triangle from a guy that's standing 90 degrees to a horizon, and Bacon's going to do it again, bringing the star down to the horizon and getting an
You
angle
don't need to do the
measurement
stupid talking, Flatzoid.
because it's frustrating. It's literally
Right, so I asked
frustrating.
you whether we could measure an angle between two random stars in the sky and whether that requires a 90, and you said yes. That ends the conversation for me.
Great. So you need a 90 degree to get an angle. Look, he's moving the star down to the horizon. Thank you, Bacon, making my point again. You're moving the star down to the... Because
Bacon,
a
do I need
sextant...
some 90 degrees to measure the angle between two stars in the sky?
Yes.
No.
Yes.
No, I mean,
Yes.
this drawing here is what you measure. You see a point there. You see a point there. You get the measurement between those two. The 90 degree exists between the green line here, which is not what you're looking at, and the pink line, which is also not what you're looking at. Those lines are imaginary. You don't need to establish them to do the reading. You first do the reading, and then you use them like conceptually to correct for your angle and get this one, which is the one you want to. So
Based
it's
on
easy.
a 90.
That's all you want.
So you need a 90 to get the co-altitude angle.
Yes, because
Of course you do, Flatzoid.
Great. So
Just move the goalpost, Flatzoid. We asked whether you could measure an angle without a 90, and then you go, oh, can we get the co-altitude without a 90? Co-altitude is literally defined as being 90 minus the elevation. Right?
So
That's
you measured.
dishonest.
So you measured 90 degrees.
My God, you're dishonest, Flatzoid.
Yo, wow.
Shifting the goalposts, and we all know that your audience is stupid, right?
Oh,
That's why I
wow.
think maybe you're not so stupid. Maybe not. Your audience is stupid because they would have missed that.
You know
But
how
moved
much
the goalpost.
concessions I got out of you tonight, Ruif? You have have you got any clue how many concessions I got out of you tonight that literally debunk every argument you guys have been presenting from the globe since this argument came out? Have you got any idea?
I would love to see them flipped out. Fantastic.
I'll actually make a video on the points, and I'll literally take a cutout and put it on to show how much you've done.
Okay. Where's Wally's already agreed to do a video on your
Where's Wally can do all he wants.
on your celestial navigation working on that.
That'll be fun.
Yeah, Where's Wally can do all he wants because Where's Wally literally debunks himself every time he opens his mouth.
Yeah. Okay. Did you want to say it again just for clarity? That your fix of 540 kilometers off the actual position is a working flat Earth fix.
You used
say it again.
Misrepresenting. My argument was you claim we cannot do celestial navigation based on flat Earth. I gave you the data based on flat Earth, and you did celestial navigation. You got a fix, correct?
540 kilometer fix.
I don't care. And then you conceded. That if you change the map, you would get a different fix, correct?
Right. Yep.
So
if you want to call it a concession, that's fine.
So same data, different map, different fix.
Yep.
Great. And the data was based on a flat measurement, like I said from the beginning.
No, this is like Oakley bullshit from like 2 years ago now, right?
No, this is not Oakley bullshit. This is me literally verbatim trying to explain to you how you've debunked your own globe argument by coming in.
Okay.
And by the way, guys, it's like literally 1:30.
540-degree error in your fix is not a demonstration of celestial
and it's
navigation
literally like
working.
1:30 in the morning, guys. So I don't think we're going to go on much longer.
It's too long, isn't it?
The third star, the error dropped to 1 mile.
Hey, nice one.
Again, Bacon, when you are standing upright, you are 90 degrees. You are taking that angle measurement of the star and you're dropping it down to the horizon, aka a succession angle, because that's how a principle of the sextant works on succession angles. It's parallel to the horizon. If you use the sextant, you would know this. And based on that, you literally just proved flat Earth. Thank you very much.
How am I
on screen
flat
now.
Earth?
Oh, sorry. No.
Yeah, how am I proving flat Earth if every time I plot those circles on a sphere, I got the right location, and I never plotted them on a flat surface to get it right?
You measured.
That doesn't make any
You
sense.
measured off of a 90-degree angle. That circle of equal altitude is based on the same plane. You can take
You
this.
can say that,
Okay. Take
but-
this. Take what you just did now, and plot it on another map. You're gonna get a difference.
Let's do it again. Let's do it again.
No, Bacon.
again.
You're gonna get a different result. Correct?
You get a different wrong result, sure.
You get a different result.
On the AE map?
You
Let's do
do-
the AE. Okay, we'll do the AE map.
Okay, let me grab
You
these.
don't get it, do you? The data.
Sure.
The zenith is
So the map. So guys, the map changes the location.
yeah, and the
The
map
data
gives you the right location.
and the data
Oh.
and the data you used stays the same.
Yep.
This is hilarious.
So the data that came from a flat map gave you your what? Gave you your what? If you measured
is
it
gonna be
flat,
fantastic.
yeah, it's fantastic because he's using a map that I don't ascribe to, like I said. And you literally
Then
make
please
him up.
show us the map that it does work on.
It doesn't matter which map you use. The point being, remember, the point being, Roof, you made a claim. It cannot be done on a flat.
365 miles.
Again.
Oh, this is fantastic. I've been wanting to do this for a long time.
I know you were. And by the way, you've literally conceded once again that the data
Okay.
is not the discrepancy of why it's off. It's the map is why it's off.
The map, correct.
I
Please show us the correct map.
Again,
It's this one.
Please show us the correct map.
Here it is. Here it is.
that's not a map.
It's not how it works.
That's not a map.
Please show us the correct. Okay, then show us the correct map. Show us the map that this actually gets you really close to where you are.
The Mercator.
Okay. Bacon, do you reckon you could get a Mercator by the next stream?
I can get you close enough. Because you
But
know
by the
why?
next-
You know why I say Mercator? Because that's what the navigators use on ships. The Mercator
We'll
map.
see, won't we?
Because they literally don't sit around using globes.
Okay.
Because it's a coordinate system, you guys. You can have the same coordinate system on a donut.
I'll try to convert this one into the Mercator. It might take me.
Yeah, do it for the next
10
next
minutes.
stream, whenever you.
10 minutes.
Jeez, that's pretty good.
That's fast. That's one thing I must respect you with that, Bacon. You're very good at this.
Yeah,
Thank you.
I'll put it out there. Bacon is one of the smartest people I know.
Bacon is awesome. I mean,
Thank you.
I feel sorry for people that don't like bacon. The smell. But yeah, thank you, Rua, for literally proving that the globe argument has been false all this time.
You're welcome, Plateau. You're welcome.
Pleasure.
What's 365 miles? This is a 2609.
It's quite a-
587 kilometers away.
Yeah, it's far, eh? By
Yeah.
still ignoring that you literally took flat Earth measurements to make that. You guys literally conceded
Do
that.
you want to talk about flat Earth measurements?
Okay, look at it. Let's look at a sextant quickly, Ruaf. That's a 60-degree angle that the top of the triangle is to the vertex arm, correct? And then it has that arc at the bottom,
Sure.
which corrects it. It's 120, so it makes it to a 180-degree triangle.
I think you can measure 120 degrees with a sextant.
The bottom arc is 120 degrees, but the triangle tip there is 60 degrees. So the 60 plus 120 makes the 180-degree triangle. It completes the triangle. You know that
Okay.
arc. You know that arc. You know why they got an arc on the bottom of the triangle?
Just get to the point where angles mean flat
Why do they have an arc on the bottom of the triangle for the sextant, Ruhf?
Earth. I don't know. Just get to the point.
Simple. It's because it's an angle measurement. It's an angular degree arc measurement. That arc that you're measuring is the celestial sphere arc superimposed, as you can put it, if I say that's the correct word. In other words,
Yeah,
you are measuring
what's your
angles.
screen?
You're measuring angles on a horizontal to a celestial sphere, which is optical, and that reading on your sextant gives you the distance of the surface, which is based on a arc reading from a 90-degree. You guys, literally, your globe, this literally using a sextant proves that your globe is basing your reality of physical surface from perspective.
Are you trying to say Oakley's elevation angles require a flat Earth argument? Like, what are you trying to say?
You literally conceded when you said the guy stands 90 degrees.
As in, that proves the Earth's flat if I stand up straight?
Try and take the same measurement without having the sextant at 90 degrees, please.
So I point at a star and point at the horizon.
Do you know what? Do you know
How
what?
is that proof of flat Earth?
Do you know what a succession angle is? Succession angle.
Succession angle.
Yeah.
What's a succession angle?
That's the principle that the what's the name works on, the sextant. It works on the principle of succession angles. Yes, succession angles. It means
What the
you
hell
need.
is a succession angle?
It means it needs to be parallel to work.
I've just googled succession angle. How do you spell it?
SUCC success ESION. Is it not?
Succession angle. I Google it. No results.
I literally showed it live on a stream recently as well.
Oh, hang on, found one. Pressure dependence of the angle of succession. What the hell is that? Oh, that's X-ray spectroscopy. Okay. So what is a succession angle with relation to a
let's maybe
sextant?
do it this way. Sextant principle. Angle. The principle of a sextant when the ray of light is reflected from two mirrors in succession in the same plane.
Oh, in succession? As in one after the other?
Yep, and then the angle between the
Jesus.
incident and reflected ray is 2 times the angle between the mirrors. Do you understand how that works?
Jesus, a succession angle. If I put quotes around the word succession and then quotes around the term succession angle, I literally get no results found for sextant and succession angle. You're
Because
just talking out your ass again.
I got it live on screen. Literally, it's showing us the principle of the sextant is when the ray of light is reflected from two mirrors in succession in the same plane. And then the
Please
angle
show where
between...
it's called a succession angle, Flatzoid.
Succession,
Not
in
doing
succession.
one thing after the other. Jesus, you're a liar. My God.
That's the principle of a sextant. How am I a liar if I got it on screen?
How is your chat not just abandoning you in droves?
Guys, is this guy literally so dumb he can't read what's on screen?
Please show me the term succession angle in relation to a sextant. I'm sharing it on screen now.
Where a ray of light is reflected from two mirrors in succession to the same plane. That means you got two mirrors, the same plane. The angles need to be parallel to one another to work.
I asked you what a succession angle is.
That's
I
what a
googled the
succession...
term succession angle with the word sextant. 0 results. The fact that it does something in succession. You asked me what a succession angle is, and I said I have no idea. What is a
I'm trying to
succession
explain
angle?
it to you.
And got nothing.
I'm trying to explain it to you. It means that the angles are on the same plane in succession. You got two mirrors on a bloody sextant.
Okay, I understand that.
Okay, so light has to travel through
The term
those.
succession angle doesn't exist.
The light travels through both mirrors, correct?
You
And
asked
the
what
light,
a succession angle
the
is.
light
It
hits.
doesn't exist.
The light hits one mirror before it hits the other, correct, Ruhuf?
You asked what a succession angle is. It doesn't exist.
That's it. That is it. He's muted. Ruhuf, you bloody incompetent cow, as I can put it. I don't know how else to put it. A sextant works with a succession of having it working together. You have two mirrors, okay? The light hits one mirror before it hits the other. In other words, succession. It has an angle to it. In other words, succession angle. There we go. If they are not parallel, they do not work. The whole reason you get people like Bacon bringing the star to the horizon so the succession angles can work. The whole principle of a sextant needs the angles to be parallel with each other so you can duplicate them to work. That's how a bloody sextant works. This is not rocket science. Okay, now I can unmute the moron. Oh, and he's gone.
Yeah, Bob the science guy was saying that he was tempted to come in and join Ruhif.
Whatever.
But the thing is, he doesn't have the bottle to come in any other time when you ask him. And now he's, oh yeah, I might come in. Yeah, he's a knob.
No, Rob, you wouldn't come in anyway because you're too much of a coward. You called Bob the coward guy for a reason. There we go, the principles of a sextant. I can't believe... I'm getting furious here, actually, as I'm sitting here. And you know me, I'm quite easy sometimes with these guys, but, I mean, this is getting too much.
Well, Ruhif does that to people.
Yeah. Okay, let's read it in other words. A sextant is... A sextant is based on an optical principles provided below. When a ray of light is reflected from a plane surface, the angle of reflection and the angle of incidence are equal. That would be the angle of succession, moron. The angle between the first and the final directions of a ray of light that undergone double reflection, angle of reflection, in the same plane between the two reflecting surfaces. In the case of a celestial navigation, the observer measures the angle between the horizon, horizontal, seen straight through the sextant, and the celestial body seen through the two mirrors. Mirror 1, mirror 2. The light has to bounce through the one mirror in succession to the other mirror. Their angles have to match parallel to the horizon for it to work. That is how you get the arc measurement on the bottom of a sextant. This is why I say you could swear these guys have never touched a sextant in their life or even seen a picture of it. The whole basis of a sextant is basic trigonometry with a triangle from a 90-degree angle. Now I'm finished.
Well, that was another long one today then. And nearly another 4 hours again, isn't it?
I can't believe I actually went on so long. It's just angles. Wow, this is sad. Okay, have you got it ready, Bacon? I don't know. I don't see him on anymore. Well, he's still on, but it's not showing anything anymore. Ooh. Yes, and guys, I do get angry because I am human. And I do get frustrated because when you get people that are so dishonest that can't accept anything. Oh. Yeah, I did trap them multiple times. Hey, Free Mind, good to see you. Thank you for coming. I don't know if Bacon's still in. But yeah, all this came from Proto.
I am.
Okay. Are you coming right, mate?
If I'm what?
Are you coming right with the coming on the new map?
Yeah, it's taking a bit longer than
No
I
stress.
expected.
No
I'll get
stress.
it.
Maker Ray says, your video shows how Flatsoid lied in his star data. Said the star with the angle of 39.5 degrees was 3,900 nautical miles to the GP. Sorry, where did I say 39? Show me a 39 degrees here, please. Maker Ray. I don't see any 39.5 degrees here. I have a 45 degree here. And yeah, it says 45 would be 3,000 nautical miles. Correct? And a 45 would show 2,700 nautical miles. Where the bloody hell did you get 3,900 nautical miles to the GP, Macquarie? So who's being the liar here? In the star data point you presented to Rua for celestial navigation. Then it's Protothad that had the wrong things, guys. The wrong distances. Because we could have gone through all of them just like this and got the right results. So was Protothad lying then, Makeray, not me? Huh. Because we read it off Protothad's video, if you haven't remembered. Or am I somehow mistaken that I wrote Protothad's data? I mean, what we did in the beginning, we showed this math gives the right distances, and then we took his distances as, well, just as faith that it corresponds with the correct data. So maybe we should go back to Protothad's videos and see if he actually gave the right data then. How's that? Let's go. Which one? Which one is 39 degrees, by the way? This 34, 65, and 50. Mike, array. The 34 is 2,000. 65 is 3,000. Oh, there we go. 34. 39. There's no 39 degrees here. It's 50 degrees, 34, and 65. 65 is...
Set our circles on a same to draw our...
There we go. 65 is 39,000 miles, Macrae. Tell me again how I said it was 39 degrees. So Macrae, you've just been proven to be a liar straight live on stream to everybody. Thank you. It's amazing how easy we can debunk these idiots. They make a claim that they literally don't understand, and then we can go and show them live how they've been lying.
Right.
Yeah, exactly, Derek. When you establish curved lines, instead of calling them angles, let me know. That's all they do. So again, thank you, Globies that came in and literally conceded you can do celestial navigation off of a flat Earth, conceding that the map is the reason you have discrepancies on your fix, not the data, conceding that the data is done off of flat. You literally did. You're doing a map now which is making that point. You're changing the map so you can change the fix.
Yeah, but just because when you change the map, you change the fix, doesn't mean you can solve the fix by solving the map. If you're going with the flat assumption, there's no map that will solve it.
Again, the data is based from a 90-degree angle. It's based from a flat horizontal angle. All the data you are using to get your fix is from flat. So as soon as you change the map to get a different data fix, fix is because it's not the data that's wrong, which was measured flat. It's the map. Now, like I said, the map is not reality. Maps have distortions. Even your globe isn't 100% based on that data. But the point is, your globe, when you show your globe bringing that fix, and you say, look how accurate it is, you are conceding the math is done from flat. So your globe is based from measuring flat Earth angles. This whole stream has literally been about that.
How can you say it's a flat Earth measurement if there's no way you can treat the Earth as flat to get the right coordinates?
You started off with a horizontal baseline to get an angle measurement. The sextant literally works off of its principle needing to be parallel to the horizon, which is horizontal. Then you need the GP of the star to be on the same plane as the observer to have that angle measurements. Your elevation angles is based off of that 90. Your data you have is based off of that 90. Then you take the data and you construct it onto your globe. Does not make it a globe. It means you've taken flat Earth measurements and then constructed it onto a globe afterwards.
Yeah, the assumptions you claim, for
There's
example...
no assumptions. There's no assumptions. It's flat.
The claims you made, for example, that the observer and the GP has to be on the same plane, those claims, they fall apart if you try to use them when you're doing the fix.
Circle of equal altitude.
Okay, what about
it? Flat.
Yeah.
Can you unhide Bob the science guy? I meant to time him out and I've hid him. And I can't unhide him. I just meant to time him out. I didn't mean to hide him.
Can I? Let's see. Unhide user on the channel. There we go. Okay.
Cheers.
Shot. You see, he said it was an accident. But yeah. Bacon, it's very simple, mate. Because I'm literally getting a headache from repeating myself over and over. You've got a measurement based on a horizontal plane. All the data, all the distances for that circle of equal altitude come from a flat plane. Because you have to literally, that's how a sextant works. It needs the angles to be parallel to the horizon. that horizon needs to be parallel to your elevation, not elevation, I mean your elevation angle requires to be working off a horizontal that's parallel to the horizon. It's all parallel rays. It's straight lines. That's why we say horizontal doesn't curve. So when you got a parallel horizontal to a horizon, it means it's horizontal. It stays horizontal straight through to the GP. It creates a right angle triangle. The trigonometry, the sextant works off of a trigonomic principle of a triangle, a right angle triangle. That's how you get the sextant to work. If you just throw trigonometry away, it won't work. That's it. It's as simple as that. Throw the trigonometry away, you don't have measurements. Your whole globe is based off of the trigonometry from a flat plane. Again, a map is not the argument here, Don. The angle measurements you're getting and the distances for your circle of equal altitude is the argument. You get it based on a flat trigonomic principle. Right angle triangles. If one glober can show me how you get it without right angle triangle trigonometry, go ahead. Because that's what a celestial navigation requires. Right angle triangle trigonometry. The sextant is built in this way, and it will always remain that way, because that it wouldn't function if you throw that trigonometry away. Okay, Bacon, would you be able to come and present this on another time, or have you fixed it already?
No, I mean, I fixed the plotting, so those circles are plotting. I mean, plotted correctly, but I'm not being able to get the fix. Is like here instead of there.
No, that's fine. Maybe you can work on it another time. You can come present it. Is that fine? Because I mean, it is 2 o'clock already. I think I should go sleep.
I can do that for multiple maps.
Awesome.
Yeah.
Wiggles is laughing, say there's no fix. Yeah, that's the Makata, by the way, Wiggles. But he'll get it right, though. You'll figure it out. It's just taking it to map it. So, but thanks for coming anyway, Bacon. I think we both can agree we definitely have different opinions on what we see.
Sure.
Yeah.
Definitely.
And I definitely got heated tonight.
Happened.
Yeah.
Anyway, I don't want to grab some.
So he can get into
Shot Bacon, thank you for coming, mate. Appreciate it. Okay, yeah, PJ, your thoughts?
Yeah. Wow. I don't know. I mean, it's like you put it right in front of them, and they walk past it because they can't see it. It's like, well, it's right there in front of you. You're just telling them, and you're putting it in the most layman term possible for them, and they're just not seeing it. I just don't get it. I don't get it.
Yeah, I tried it in so many different ways. I obviously literally I feel triggered because after explaining yourself for 4 hours, the same thing over and over in different ways, you literally get angry. Because
absolutely.
It's like talking to a wall.
I understood that. I mean, then he comes out, starts whinging because I timed him out, and it's like, I timed you out because you're a
liar.
Condescending prick. Exactly.
He literally lied on the stream. I mean, he was so dishonest. He can't even answer me when I ask him a yes and no question, over and over. He literally threw his trigonometry away, threw his own globe arguments away, and then claims I'm being dishonest somehow. And how much times did he try and add on me and break my character by 11 frames and get triggered and stuff? Yeah. I got angry. I didn't call him like that. I literally told him he's a moron because it's factual state after showing him on screen what's going on and explaining to him.
Yeah.
So yeah, guys, from now on we can take the stream, and every time a glober brings up, you can't do celestial navigation on a flat Earth. We will bring this up and show Ruhif did it for us. Then they come and tell us, oh, but the maps are wrong and it can't be fixed. And we say, but it's not the map that's a concession, so it's a straw man. It's you conceding then your globe comes from flat, because the data, which is in concession because it's based on a 90, is based on a flat Earth. And then you take that data and correspond it to your globe, which is you conceding your globe is measured flat and then based on a globe. Also conceding then that it's just perspective. Your whole globe is based on perspective and calling it physical. A lot of concessions, a lot of running away, a lot of literally ignoring trigonometry and throwing it in the dustbin when it doesn't suit them. And also when he thought I'm not going to get the right answer and I did, and then he's not happy that I didn't give him how I got it.
That you got it, yeah. And how did the guy deny the right angle triangles when you were on about the Polaris and that? I mean, that's always what I've thought it to be. I've always thought it being when you've got the 90 perpendicular to the horizontal. What I mean, I've always thought of it as a right angle triangle. Always have since school.
Yeah, exactly. I mean, that's literally what the sextant is about. The sextant is about trigonometry of a right angle triangle. That's it.
You know what? I'm from a fishing town. I've never used a sextant. I'd like to give it a go actually.
Yeah,
I've
you
never
should.
used one. But yeah, you would have thought I'd use one being from a fishing town. But
Well,
no.
I don't need to use one because I'm in the bush. I can literally just use this. I can use the Southern Cross or the moon or sun if I need to. So I don't need a map and a sextant to use, but it doesn't mean I don't understand the principles of it.
Oh, of course,
Yeah.
absolutely.
So it's very simple stuff, guys. If any glober, being honest with himself, can say a sextant is not based on right angle triangle trigonometry, then how are they going to be honest with the rest of the discussion? They can't.
That's it.
And it's as simple as that. And they can bring up any citation they want. It's always going to show trigonometry done with a right angle triangle. Always. Because that's the basis of a sextant. That's its principle. The succession angles, the angle comes in succession based on the two mirrors. Full stop. Telling me I'm lying while I'm showing it on screen to everyone.
Oh no. I know.
So yeah, that was about it.
Ruhif and his fake laugh.
But yeah, thanks guys all for coming. Thank you, PJ.
No problem.
It was
No
good to
problem.
see you all, but yeah, I really have to go sleep. 2:05. Getting up for church in at least 4 hours. At least I'll get more sleep tonight than last night.
Well, yeah.
Well, it depends if the children wake me up at the same time. But yeah, so thank you all for coming. I'm definitely going to take a lot of inserts out of this, because I'm going to make a video where Ruhif literally says something and I make a list on the side where this is what he's conceding to.
Yeah.
So
you've got like nearly 9 hours in 2 days. 9 hours of stream.
Crazy. It's crazy. But but it's good to see everybody came. It's good to see everybody had a laugh. I'm glad you guys enjoyed it. It was frustrating for me, to be honest. The beginning was fun until Ruhif came in with his dishonesty. Bacon I can still take because he's not really, how can I put it, well, although he also did the same things as Ruhif when he doesn't want to accept the 90, but he literally drew it on screen, so he conceded it. So yeah, thank you guys all for coming. Yeah, I'm going to condense this in a nice short kind of manner, so every time a glober says sextant for globe, we just show them that. And yeah, then they don't have an argument anymore. So thanks all for coming. Really appreciate you all coming. See you guys tomorrow night. Many, many blessings, and may the pressure be with you. Cheers.